Hey guys, welcome to this video. So this is going to be a grade 12. I don't know why this stuff isn't added here. I know normally it is, but I think it's because it's a June exam. It's a grade 12 June exam paper, and it's a paper 150 marks, 3 hours. If you would like to download this paper, just click the link that you see below the video, and then you can just see all the different questions, and then you can fast forward to the place in the video that you would like to have a look at. All right, wishing you guys all the best with this paper and also just in general with life. I hope you guys are doing well, and lots of love to all of you. See you in the video. With this question, we have to solve for x. Now, we're probably going to be able to just use brackets. You could use the quadratic formula if you want, but because they didn't say here, for example, usually they'll say here like to 2 decimal places or something like that. Then you need to use the formula. So for something like this, we can make 2 brackets, and then we can say x and x. Now, the number 15 is the same as 5 times 3. Now, if you take the number 5 and you take the number 3, how can you make the number 2? Well, you could say 5 minus 3. So we'll put a 5 here, which will be a positive, and a minus 3. At this step, you can now say x plus 5 must be equal to 0, or x take away 3 must be equal to 0. And if you solve, you end up with x equals to negative 5, or x equals to 3. In this question, we have to solve for x. Now, when they say leave your answer to 2 decimal places, that should be a little bit of a hint for you that it's not going to be able to factorize using brackets, okay? Because if it was, then you wouldn't be ending up with decimals in your final answer. So what we'll rather do with a question like this is use the quadratic formula. You know, the one that goes x equals to negative b plus minus square root of b squared take away 4ac over 2a. Okay, so you're going to go fill all of that in like this. So remember that this letter here is a, or that number. B is this negative 1, and then c would be negative 9. So you're going to say minus, because there's a minus over there. Then what is the value of b? The value of b is negative 1. Then you're going to say plus and minus. And then in brackets, you must put the negative 1 squared, because that's b squared. Take away 4, and now what is the value of a? The value of a is 5, and then c would be negative 9, and then all of that is going to be over 2, and then what is a again? 5. Okay, go ahead, type that all in on the calculator, just like you see it. Of course, you can't use a positive and a negative at once, but you can choose a positive for one of them, and then a negative for the next answer. And if you round this to 2 decimal places, like they said, you'd end up with 1,45 for your first answer. Or, now for your second one, you could change it to a negative, for example. And that'll be negative 1.25. For this question, we have to solve for x. Now, a huge mistake that I see learners doing all the time is, so this part here is going to be wrong, okay? Whatever you do here, this is wrong. So if you say x squared divided by 3x, then a lot of learners, they're like, oh, dude, there's an x on both sides, so we can just be like, do that. Done. Next question. 4 marks in the bag, yo. But remember, that's not correct at all, okay? So you can never divide by x like that. Okay? Don't worry, I used to do this when I was a student at some point. So I know, okay? So what you do instead is you do the following. Okay, you take the 3x to the other side, and there you do it like that. Then what you do is you factorize. So what could you take out of both of these? Well, you could definitely take out an x, and then you'd be left with x take away 3. Okay, now, because it's an inequality, what some students do, this is also wrong. Check what I'm about to show you now. It's also wrong. They say, okay, they pretend that it looks like this. Okay, if it was like this, you would then say x equals to 0 or x minus 3 equals to 0. Okay, so then what students do is they see, okay, well, if we then have this, oh, and by the way, what I showed you over here, that would have been correct because it was an equal sign. But if you have an inequality sign, what a lot of learners do, they're like, okay, x must be smaller than 0, or x minus 3 must be smaller than 0. Completely wrong, okay? So, Kevin, what do we do then, my bro? Because you're just telling us everything that we're doing wrong, so how do we actually do this? Okay, so what you do, guys, is you need to pretend that this was an equal sign, okay? You pretend it's an equal sign, and then what would your answers be? Well, you would end up with x equals to 0, or x minus 3 equals to 0, which means that x is equal to 3. Now, these are not your answers, but these are called critical values, okay? Your teacher probably calls it that, but might call it something else. But those are the numbers that you're now going to go put on your number line, okay? So you can go put, and in order, hey? So 0 comes first and then 3. Now, there are different ways that you can do this next part, okay? One of the ways I like to do it is I look at this. And I know that whenever we have a term, or whenever we have something where the highest power is x squared, then I know that if I had to draw this as a graph, it would be a parabola. And a parabola can either be a smiley face parabola, you see how it's smiling over there, or it can be a sad parabola. Okay, now the way that, oh no, the eyes would not be there, Kevin, the eyes would be there. So the way that you would know is by looking at the x squared term. You see how it is a positive number in the front here? There's not a negative. So this is a positive parabola. It's a smiling parabola. So I'll put the smiling parabola going through those 2 points, because those 2 points are technically the x-intercepts if you were drawing a graph. Oh, come on, Kevin. You can do this, dude. Okay, guys, you get the idea, right? I'm trying to go through those 2 points. So that's what your parabola would look like, okay? Now, if you look at this part over here, this part, they are asking you, they're saying, hello, where is this parabola, okay? Where is it? Now, what does this mean? Does that mean where is the parabola smaller than 0, or where is the parabola bigger than 0? Well, this is saying where is the parabola? Well, let me try explain this thing to you, because some learners really struggle with these signs, and instead of me just going over it, instead of me just skipping past, let me try explain. So I've got the most lame way to explain it, but hey, some learners like it. So this is a crocodile, okay? Not really the part at the bottom, not that part, but this part. Can you see the crocodile? Can you see the big teeth? Okay, that is a crocodile. Oh, it's a weird crocodile. It's like a crocodile that's like 65 years old and all its teeth are falling out. Okay, so that's a crocodile. I hope you can see that, okay? Now, that crocodile, if you look at the direction that it's about to face, what is the crocodile trying to eat? Is it trying to eat the 0? Or is it trying to eat this side over here? Well, I'm hoping that you can realize by my horrible drawing that the crocodile is facing the 0. So the crocodile's about to eat the 0. Now, the golden rule to remember is that crocodiles are super hungry creatures and they always like to eat the biggest food available. Okay? So crocodiles, and I know this is lame, crocodiles always eat the big stuff. Okay, so that means that the 0 is big, so the 0 is big, and then this side is the smaller side, okay? So the x minus 3, that must be the smaller side. So what we can say then is that this part, which is the parabola, we can say that the parabola is smaller than 0, because the parabola part is smaller than the 0 part, because the 0 part is the big part, because the crocodile's eating that one, okay? So the parabola is smaller than 0. So when we look at this graph now, when they say where is a parabola smaller than 0, they're not talking about this 0, by the way. They're talking about the y values. So anything, so if you highlight this part over here, anything under that is where the y value is smaller than 0, and anything above that yellow line is where the y value is above. So they want to know where is the parabola smaller than 0. So where is the parabola below the yellow line? So if you now take a highlighter, you can see at this part here the parabola is above, so we don't want that. But then look at the graph over here. Can you see that the graph for that blue part is below the yellow line? So this is the part where we are interested in, okay, this part here. Now, when you give the answer, you can tell them, you can use the x values to tell them where it was. So you can see it's this whole blue part over here, right? Now that blue part goes from x equals to 0 up to x equals to 3. So you could either give the answer with interval notation, by saying that x is an element going from 0 up to 3. I am including both of those with square brackets because they also said we can include it. And then if you would like to rather use set builder notation, so you could say then that x is any number bigger than 0 but smaller than 3. This question says, given this expression over here, solve for a. So the first thing I realize is that there is a denominator. As soon as there's a denominator, you need to then go find a lowest common denominator. So I would put all of these over 1. Can we all agree that the lowest common denominator would be a? Okay, so that's going to be a. So what that means is if I go write this out a little bit bigger, I need to turn all of these denominators into a. So I can multiply this by a, but what you do to the bottom, you do to the top. This one I don't need to do anything because it already has an a at the bottom. This one I'm going to multiply by a, and what you do to the bottom, you do to the top. If we then go rewrite it, we're going to end up with a squared over a plus 64 over a equals to 16a over a. Now some learners, I've seen this in the past, and I used to think about this when I was like in earlier grades when I was younger. I would be like, yeah, but now I can just cancel this out, and I can just go cancel this a out. But then you're just going to get back to here, guys, and that's not really the point, okay? Because what we're trying to do is get to this point where we realize, all of the denominators are the same. Now, in mathematics, when you have an equation where all of the denominators are the same, you can leave the denominator. So now we end up with a squared plus 64 equals to 16a. Now we can just solve this like a trinomial by just bringing the 16a over to the other side. So we end up with a squared minus 16a plus 64 equals 0. Okay, now you can either solve this with the quadratic formula, or you can solve this using factorizing. This one will factorize quite nicely as a minus 8 and another a minus 8. You can just pause maybe and check that you agree with me on that. But a times a is a squared, and then negative 8a plus 64. So that works out perfectly. Then we can just solve and would see that a minus 8 is 0. Therefore, a would be equal to 8. Now we got to take that and somehow do this. And it's just like, what? Okay, so there's not much we can really do here. Like, you can't take out a common factor. You know, sometimes we get those questions where it's like 3x plus 3x minus 1. And then you would typically, and you would have like equals to 15, for example. And then what we would do here is you would break this up into, like 3 to the x and then 3 to the negative 1. And then we would have a common factor over here of 3 to the x. That's normally what happens. But if you had to do that here, it won't work because you're going to end up with a 2 to the x and a 2 to the negative x. That's the problem. So watch carefully, guys, because I've actually seen questions like this quite a few times, so that you could get this in any test or exam that you do. So what you do is the following. You say 2 to the x plus, and then you do break this up, okay, into 2 to the 6 and 2 to the negative x. That part there, you should be comfortable with what I've just done there. If not, then let me try explain. So let's say you had a to the x multiplied by a to the y. If you do exponent rules, what does exponent rules tell me? Well, let me start with more basic. What is a2 multiplied by a3? No, it's not a6. If you said that, just think carefully. What you have to do is remember that these two would add to become 5. So we could also add these two to become x plus y. Okay, but now this is a mathematical property now. So you can go this way and you can go this way. Okay, so can you see that over here we have this part? You see how we've got the two parts at the top here. But then what I'm doing is I'm rewriting it as the individual parts. And that's what I did over there. You see that? See how I changed it from 2 to the 6 minus x, and I changed it to 2 to the 6 and 2 to the negative x. In the same way that you would have a to the x plus y, and then that can just become a to the x and a to the y. Okay, good. Hope you understand that. And so then this would be equal to 16. Now, you can't take out a common factor here. A lot of you are going to look at this and you're going to be like, could I do something there? No, you can't. But what you can do, and I've seen these questions many times, so if you practice enough, you will get used to these. This here, how can I take that negative? how can I change this from a negative to a positive? Well, think about this. If you have x minus 1, or let's rather say x minus 2, how do you change that to a positive? Well, you can say 1 over x2, right? You understand that property. If you have like a to the negative 3, then that can become 1 over a to the 3. Yep. Okay. So what could we then do with this? Well, what you could then do at that is you could say 2 to the x plus, and now this is already at the top, so just leave that over there. And then you could take this down to the bottom as 2 to the x. Now some of you are like, Kevin, where's the 1? My bro, where's the 1? You know how earlier you showed us when you had this one over here, you said 1 over? Yes, good question. So that 1 is only there if there's nothing else to fill in the space. For example, it's pretty awkward if you take this and then you put it at the bottom, because look here, you've just, what's at the top? There's nothing there. So when there's nothing there, you put a 1. But in this example, there already was a 2 to the 6 over there. So that's like a placeholder. So you don't need the 1. Okay? And now all of a sudden, look at this, guys. I think we are in business. Because this expression is starting to look a lot like this expression. Now, did you know 2 to the 6, if you go type it on your calculator, that is 64. Now we're really starting to look like it's similar to this. It's actually identical. Okay, so check this out, guys. Oh, I love maths. It is beautiful. And some of you are like, okay, cool. That's great. I'm glad you enjoy maths. But Kevin, I just want to get the question done, please. I want you to now look at these two expressions and see what is the same and what is different. Okay, so can you see that they both have that 64? They both have that 16. So that's all the same. Can you see that this one is an A, but this one is a 2x, and this one is an A, and this one is a 2x. So what we can do then is we can do the following. We can just make a rule. We can say let's rather let the 2x be equal to A. So then we end up with A plus 64 over A equals to 16. Okay, now we know how to solve this. We already solved this earlier. And what did we get as our answers? 8. So what we can then say is that A is 8. Right? We know that. But we also just said that 2x is also A. So we can say that 2x is then going to be equal to 8. Oh, Kevin, this is so cool. I know, right? And then, and then I hope that's what you guys would be saying right now. And then we can then go solve this. Okay, so for example, you could see that 8 is the same as 2 to the power of 3. And then the 2's can cancel, and you end up with x equals to 3. And there we have now solved for x. Without using a calculator, okay guys, so just chuck your calculators away. No, that was a joke. Guys, when they say without a calculator, you can still use a calculator just to give you like a bit of help. I'm not saying you need a calculator for this one, but don't be too extreme when they say without using a calculator. Like, you know, when you're sitting an exam and it says without using a calculator, and then there's that like old Tani who's walking down the aisle and she's coming towards your table. Trust me, those people that they get from the external, they don't even know what you're busy writing about. Like, they couldn't care less. They are not looking at your question and says, ooh, look, calculator, and look, he's using a calculator. Ooh, we're going to report him. No, they're not looking at that type of stuff at all, okay? You can use your calculator, but the way that you present your answer, that's where they're going to be able to check, were you using a calculator, okay? So don't freak out when they say this. Don't like put your calculator under your desk or something. Okay, so you guys probably don't do that anyways. Maybe I was the only one who had that feeling when I was a student. I don't know. Anyways, let's move on. So without using a calculator, calculate the value of this. Okay, so whenever you get a question that is like 2 to the 1002, well, not an equal sign, plus 2 to the 1000, and I know this says 6, but I'm going to just change it up. There we go, 2008. Okay, whenever you get something like this in mathematics, I want you to do this. Take out a common factor. The common factor will always be the lowest one, okay, the lowest one. And then you open up a bracket. And then what would you be left with over here? Well, there's nothing there, so you'd be left with a 1. And then here you'd be left with 2 to the power of 6. Why is it a 6? Some of you may be asking. Well, if you had to multiply these two together, by the way, this is just an example that I'm busy showing you. Some of you are going to look at this and be like, it's meant to be a 6 over there, sir. I know, I'm just doing an example quickly. So if you did have to multiply these two together, let's say we did multiply those two together, and then you just stick to exponent rules, for example, a to the 10 times a to the 3, many of you would be comfortable by saying that this is becoming a to the 13 because you add. So if you had to then say that this would become 2 to the 1008. Okay, you see? So that's what you would do over there, okay? So yeah, get into the habit because you will get these types of questions. They like to ask them. So we're going to go do the same type of technique and let's see if it works out. So we're going to open up a square root and we're going to take out a 2 to the 1002 as a common factor at the top part. I don't care what's happening at the bottom right now. And so you're going to be left with 1 plus 2 to the power of 4. Okay? Right, now at the bottom, you're going to be left with 17, and I have no idea what we're going to do at the bottom. Don't worry, it's all going to work out. Check this out. If you know that 2 to the 4 is 16, and 16 plus 1 is 17. Ooh, and there's a 17 at the bottom. So what happens is we can just do this. We can then say that that becomes a 17. At the bottom, we also have a 17. Okay, so these 17s can cancel. And so you're left with a square root of 2 to the 1002 at the top and 2 to the 998 at the bottom. Now, don't just be like, oh, bro, cancel out. No, that's not the way it works, remember? If you always have to think about this. If you have like a to the 7 and at the bottom you've got like a to the 4, you don't cancel out the a's. What do? You say a, see the a stays there, and then you subtract, and then you get 7 minus 4, which is 3. But notice that the a is still there. But suddenly when we have numbers, students just want to go cancel it out. And remember, when I'm telling you guys the things you're doing wrong, it's because I did it when I was a student many times. And then also from teaching lots of students, I see all of these things. Okay, so, but it was mostly because of my mistakes when I was a student. I was such a bad student, and like, I've told the story many times, but like in grade 9 and 10, I was like, I remember in June, no, not June, it was the June exams of grade 9. I got like 21% for my exam. And I remember at the end of grade 9, driving to go fetch my report. I was with my mom, and I was in the car crying. My mom had to, I think I did go in to go get my report, but I was crying in the car, guys, because I honestly thought I had failed. And then I opened my report and it said Kevin has been promoted to grade 10. And I think I got like 40% for maths or something. And I still went and did pure maths. Crazy guy. But yeah, so I was not the best student in the earlier grades, like grade 9, grade 10. By some miraculous reason in grade 11, it was like June of grade 11, somewhere around there, I just had some weird thing happen to my life where I just decided I'm going to become a beast student. And I just started studying like every single day. And I even dropped computer applications technology and I took physical sciences. Like, listen to that carefully. So it was the end of term 2, okay? So I only started physical sciences in the beginning of term 3 of grade 11. Did you hear that? And here I am teaching maths and science. So my life just changed. I just decided I'm done with this lazy way of living that I've been busy living, and I just started studying like a beast. And my whole life changed. Like after high school, I went to university, did 4 years of engineering, and then after that, I just started teaching students, and boom, here we are. So anything's possible. I decided to stop being lazy. I'm not saying you lazy if you're struggling. I just know that I was lazy. I wasn't lazy necessarily. Like I wanted to do well, but I was a bit lost. And then I just decided, what happens if you take a human being and that human being just decides to put all of his attention onto one thing, and that's academics? What would happen? And the proof's in the pudding. I literally transformed my entire life, and all my marks improved. And at the end of matric, I got 91%. And remember, I only started physical sciences grade 11, term 3. So I had to catch up all of grade 10. The psychologists at the school were very unhappy with me. They were like, dude, you are literally going to fail all of your subjects. It is impossible to catch up all of this work. And I was like, hush, hush, hush. I've got a new energy and I'm going to do this. And I did it. So yeah, if you want to change your life around, just make that decision to just cut out all the bullshit and literally just stop wasting time on nonsense. Put all of your energy into your academics. I'm not saying become like antisocial and drop all of your friends. I mean, if you want to do that, that's okay. But I'm not saying that that's what I did. I didn't just not have any friends. I tried to at least do some social things on the weekend, but during the week I was like a beast mode. I was just like, and I was doing a lot of exercise as well, so it would be exercise once a day and then study like crazy. Yeah, okay, so I understand the struggles of a mathematics and science student. Okay, I was really average until I changed my life around, and that was the best thing I ever did. Okay, so what happens here is that we stick to the basics of mathematics here, and we don't cancel these 2's out. We leave it as a 2, okay, and then we subtract, because that's what we would have done over here. And so you end up with 2 to the power of 4. Now, what is 2 to the power of 4? It's 16. What is the square root of 16? It is 4. So the answer is 4. This question says, solve for x and y simultaneously. It's so beautiful right now. While I'm recording this, there's a sliding door behind me, and it's raining today, and I can just hear the raindrops outside. I love it. It makes me feel so cozy. And to my left on my table here, I've got a cup of coffee that I've just brewed. It's the small things in life that make me happy, like this, having the rain outside, being able to sit in my cozy room like this and make videos for you guys. It's heaven. I love it. So this one says solve for x and y simultaneously. Okay, so what you do is you take the easiest looking expression. Which is the easiest looking expression? Well, for me, it would be that one. And you would want to get x or y alone. So I would look at this y over here, because I don't like this x because it's got a 2 there. And that means we're going to have to use division and blah, 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 blah. So I'd rather take this y and try get it alone. That it doesn't matter if you get it onto the right-hand side or onto the left-hand side. So I'm going to take this y over to the right. So you end up with 2x take away 2, because I took that 2 to the left, equals to y. There we go. There are still some learners, I don't blame you. It's from the teachers that brainwashed you. I'm not saying teachers are bad, by the way. I'm just saying you get certain teachers that maybe don't understand the work that they're doing as well as they should. And they always say, you have to get the thing that you're looking for on the left-hand side. You have to, okay? And it's absolute nonsense. No, you don't. So here we have y by itself. So we know that y is then equal to 2x minus 2. So what we then do is we take that and we put that into this expression. What, Kevin? I don't understand what you just said, bro. Sorry, I said that a little bit quick, eh? So you see there's a y here, and you see there's a y here. Just replace this y with that. Okay? So that's going to be 1 over x, take away. And of course, I should be giving like little labels here. So we could call this equation 1, equation 2. This could be called equation 3. And then we could say substitute equation 3 into equation number 2. Okay? And so what you end up with now is 1 over x, take away 3. And then in brackets, always use brackets when you do this, change it to 2x minus 2. So you see what I did? I just put that in the place of y. And then that's equal to 1. Now we're just going to go multiply that 3 into the bracket. So that'll become negative 6x. Negative 3 times a negative 2 just becomes a positive 6. Equals to 1. I'm going to take the 6 over to the other side. I mean, there's so many different things you could do right now, but I'm going to take that 6 over to the other side. So we end up with 1 minus 6, which is negative 5. See the fraction? Whenever you get a fraction, you need to get a lowest common denominator. Okay? So the lowest common denominator here, if you think about all of these are over 1, then the lowest common denominator would just be x. So let's quickly go rewrite this. 1 over x, take away 6x over 1 equals to negative 5 over 1. So we are going to go multiply this by x, and what you do to the bottom, you do to the top. We're going to do it over here. You multiply by x and multiply by x. Okay? Ooh, that was ugly. Let me do it again. Okay, so we multiply by x at the top. Let's just rather say dot and dot and dot x and dot x. Why didn't I do anything to this one? Well, because it already has the denominator. Now we end up with 1 over x, take away 6x squared over x, equals to negative 5x over x. Now, I've had learners say, Kevin, why don't we just cancel these x's out now, my bro? And we can also do it over here. Now, technically, that's not wrong, but then you're just going to get back to this position over here, and we don't want to be going in a circle, okay? So the reason we like to leave it like this is because of the following. In mathematics, when the denominators are all the same, you have an equation, you can ignore the denominator. So now you just end up with 1 take away 6x squared equals to negative 5x. And there we have some type of equation where we can solve. So we're going to take all the things to the one side and then make the other side a 0. So you can decide to take everything to the left or take everything to the right. It doesn't matter. I feel like taking everything to the right, because then I know that this will become a positive, and I just feel more comfortable like that. But it doesn't matter. And then this would be a negative 5x, and then you'd have to bring this one over to become a negative 1. Okay? If you took everything to the left, it doesn't matter. You're still going to get the same answer at the end. At this position over here, you have two options. You could either try to factorize this one if you are feeling brave, or you can just do what I'm going to do and use the quadratic formula. So that's the x equals to negative b plus minus b squared, take away 4ac. Oh, this formula, hey? How many times have we said this formula? And then I remember, I bet the first time you ever saw this formula, you were like, whoa, bro, like, how am I ever going to remember that? And now it's just like, geez, if someone had to come to me on my deathbed one day and be like, just recite the quadratic formula, I'll say it in like 7 different languages. Okay, not really, but, you know, we know it pretty well, don't we? Okay, so we need to go use that formula now. So remember that this part here is A, this part here is B, and this part here is C. Okay, so we're going to say, you see how the formula starts with a negative. So just put that negative there. Then what is B? B is negative 5. So put it in a bracket because you've got the negative vibe going on over there. And then you're going to say plus minus, and then you're going to say square root. And then, okay, if you're so cool, Brew, the way you just said vibe. I just realized I said vibe now. It's not a word I use a lot at all. That's interesting. So B is going to be negative 5 squared. I'm running out of space, aren't I? And then A is going to be 6. And then C is negative. Oh, come on. Sorry, I'm going to redo this because some people are going to comment and be like, so could you maybe just try to do a little bit neater next time? I understand you're doing like a nice favor here for everyone by showing us how to do it, but if you could maybe just, you know, in future, maybe just be more considerate with your space. Okay, so to all those people, I'm doing this for you. So if B is negative 5, no one's actually ever commented that I've actually seen, but I'm just imagining it'll be quite funny if someone did. Okay, so plus minus negative 5 squared, negative 4. A is, what is A? 6, and C is negative 1, and then at the bottom we have 2 times A, and A is 6 again. Okay, go ahead, type this all in on your calculator. Obviously you can only use a plus or a minus, you can't use both, so you need to go do this 2 times, and okay, so if you use a positive at the top, you get an answer of 1, and then if you use a negative at the top, you get an answer of negative 1 over 6. Okay, we're not done, guys, because remember we're doing a simultaneous equation, so we have to solve for x and for y. Okay, so I'm just going to erase a little bit of space now. I'm hoping that most of you have passed that point in this question. Okay, so what we do now is we then take those two answers, which is x equals to 1 or x equals to negative 1 over 6, and we're just going to go plug it into this equation here because we're trying to get y. So we could just say that y is equal to 2 times 1 minus 2, 2 times 1 minus 2. You see what I did there? I just took that x value and I plugged it into there, okay? So you would end up with y equals to 2 minus 2, which is 0. And then for the second one, it's going to be 2 times negative 1 over 6, minus 2. So I just plugged it into there. And if you had to go do that, you end up with negative 7 over 3. And so there we have all of our answers. We've got the two x values and we've got the two y values. The first term of an arithmetic sequence is negative 1 and the seventh term is 35. Determine the common difference. Okay, there are two ways that students like to do this question. So with option 1, we'll use like some type of simultaneous approach. And then option number 2 is we'll use the jump method. Okay, I'll call it the jump method. So with option number 1, they told us that the first term is negative 1, okay, and the seventh term is 35. So what we can do is just take this one. Now term 1 is just a, right? So we can just say a is negative 1. And then for the arithmetic formula goes like this. So we're just going to go fill this in now. So they said term 7 is 35. Now some learners get confused. Where do we put the 7 and where do we put the 35? They get confused with what goes there and what goes there. So what you got to remember is that the term number is what we call n. So that's the 7, okay? And then the value of the term is 35, and that goes here. Okay, A was, I'm just going to leave it as A for now. Position number 7 goes over there, and then D. Now here's where we use simultaneous. So A is negative 1, so we can put that over there. So we get 35 equals to negative 1. 7 minus 1 is 6. There we go. If you had to go and solve this equation, you should eventually end up with D equals to 6. Okay, now option number 2, a lot of learners like to use this one as well, but I think more learners prefer this one. So what you do is the following. You know that term 1 is negative 1, okay? Then you've got term 2, term 3, term 4, term 5, term 6, and then there's term 7, which is 35. So what they do, the learners that enjoy this one, what they do is the following. They realize that to go from here to here, how many jumps is that? 1, 2, 3, 4, 5, 6. Okay, so imagine that. There are 6 jumps. Now, to go from minus 1 to... Okay, so let's just say that there were 6 jumps. Okay, now how much distance did we cover? Well, we went all the way from minus 1 up to 35. So how much is that? If you go from minus 1 up to 35, that's 36, right? To count from minus 1 to 35, that's 36. So check that out. 6 jumps gave us 36. So what would 1 jump give us? 1 jump, if you say 36 divided by 6, that's 6. And that's D, because what is D? D is the difference between each little jump. So 1, that's a jump, that's a jump, that's a jump. So what we're saying is that each jump, which is D, is 6. And look, we got the same answer over here. So, yep, you must just choose whatever you're comfortable with over there. Okay, now we're going to move on to this one. So it says that what is the number of terms in the sequence if the last term is 473? Okay, so for this one, you write down your formula, Tn equals to a plus n minus 1 times d. Now we know what a is and we know what d is. Those are constants. Now they said that the last term is 473. So some learners are going to put 473 over there, and then other learners are going to put 473 over there. You got to ask yourself, what is this 473? Well, that is a number in the term, okay? So that's going to go here, all right? So it's going to go 473, and then a is a constant, which is negative 1. N we don't know, and then the common difference we worked out in the previous question as 6. Okay, so now it's just a matter of solving. So I'm going to take this negative 1 to the left, so we end up with 473 plus 1 equals to n minus 1 times 6. Now, you can multiply the 6 into the bracket if you want, but I'm actually going to divide by 6. So if you add these two together, you end up with 474. And then n minus 1 times 6. So I'm going to divide both sides by 6. So we end up with 474 over 6 equals to n minus 1. What is 474 divided by 6? Anyone? Just joking. I'm putting my calculator. And so that's going to be 79 equals to n minus 1. Take the minus 1 over and you end up with n equals to 80. So that means that there are 80 terms in this pattern. This question says, what is the sum of the first 40 terms in the sequence? And so here we've got the formula sheet. And so we are busy with an arithmetic pattern. Okay, so that's either going to be this formula or this formula. But in that question that we've just read, they're talking about the sum. Okay, so we would then use this formula over here. So that's going to be Sn equals to n over 2, 2a plus n minus 1 times d. So they want the sum of the first 40 terms, so we can say 40 over 2. A, what was the value of a? We already worked that out. Oh, they told us here was minus 1. Term number 40, so we put 40. And then the common difference we got as 6. Go ahead, type that in exactly as you see it on the calculator. And that gives you 4,640. This question says that we have 75, 53, 35, 21 is a quadratic. So, okay, quadratic number pattern. Write down the fifth term. Okay, so that should be pretty straightforward. It's only for 1 mark. So if we go 75, 53, 35, and then 21, then if you look at the difference from the first one to the next one, you're going to say 53 take away 75, and that's negative 22. Don't say positive 22, it's negative 22. And then 35 take away 53 is negative 18, and then 21 take away 35 is negative 14. Okay, now to work out the second difference, because that's what a quadratic is you're going to take this one minus this one. Okay, it's always the one on the right, take away the one on the left. And so that's going to end up being a 4, and then this one would also be a 4. Okay, so if we then had to carry on, then this would be a 4, so then this would be a negative 10, so then this would have to be 11, because it's 21, take away 10. And so the fifth term is 11. Now here it says determine the nth term. So we know a quadratic is Tn equals to an squared plus bn plus c. Then we know, well, I mean, there's different ways of doing this, but the way that I use is I know that I circle these first 3 numbers over here, and then we have formulas. So 2a, 3a plus b, and then a plus b plus c. Okay, so those are the 3 formulas that we use. So we start at the bottom. So we're going to say 2a equals to 4. Started from the bottom, now we're here. Cheers to you if you were thinking that as well. If you weren't, I apologize. So 2a is equal to 4 for that awkward moment. So 2a is equal to 4, and then if you divide, you end up with a equals to 2. Okay, so we have a. Fantastic. Then you go up 1 level to this one over here. So that's 3a plus b. So you say 3a plus b equals to negative 22. A is 2 from the previous part. Okay, and then you just say 6 plus b equals to negative 22. And so if you had to take the 6 over, you'd end up with negative 28. Okay, so we have a is 2 and b is negative 28. Then you choose this one. So that's a plus b plus c equals to 75. So a we know as 2. B we know as 28. And then c we can calculate. And so if you had to calculate c, you should eventually get 101. Okay, 101 Dalmatians. So if we then go for everything in, we end up with Tn equals to 2n squared minus 28n plus 101. Now always do a little safety check for yourself to make sure you haven't maybe done like some small mistake. So choose one of these numbers. I wouldn't choose the first one. I would choose like one of the ones towards the end. So let's choose this one. Okay, so that is 21. So what you do, and what position is that? Well, that's position 1, position 2, position 3, position 4. So let's go plug a 4 into all of those places. So that'll be 2, well, I'm going to run out of space. So you go 2 times 4, take away 28 times 4 plus 101. And let's see what we get. We get 21, and so we've done it correctly. Okay, because sometimes it's easy to make a small mistake that you might not pick up. But if you do that little safety check, you can you can pick it up, and then you'll go look, and maybe you just changed a positive to a negative, or you made like some type of small mistake. Okay, plus 101. Okay, so we have the formula. This last question says, determine the maximum value. Okay, so we know that, or let me rather explain. So if you have a quadratic, listen carefully, this is important. If you have a quadratic number pattern, like something like this, that is a parabola. Do you agree with me? It's a parabola. You see how it's got the x squared, but here we just use the letter n squared. So it's a parabola, okay? It's either a sad parabola or it's a happy parabola. It doesn't really matter. But if they ever ask you to find the maximum or the minimum, then it's these positions over here, right? Those are the minimums and the maximums. So that's just the turning point. Now we know to find a turning point, you can use the formula negative b over 2a, okay? So that is how you find a minimum and maximum of any parabola. So we need to just go get this thing's formula, all right? Because it's not the same as this one. So remember that any quadratic formula is a parabola, and to find the minimum or maximum of a parabola, you use minus b over 2a, okay? Now, usually, because they've included this question with this question, there's normally going to be some type of relationship between these expressions. And there is a relationship, but not everyone's going to see that. So what you can do if you ever wanted to, let's say you can't see the relationship, I'll explain what that relationship is shortly, but what you could then do is just ignore this one and just go restart this question all by like brand new, and you could go work out the formula for this one, you know, the an squared plus bn plus c. So you could go work out the a, b, and the c, okay, and you wouldn't have to worry about this one at all. Okay, so Kevin, what is the relationship? Well, if you look carefully, I looked at this part here, 53, and then I saw there was a 5. Okay, so then I thought maybe they're dividing by 5. So then I tried to divide this number by 5, and I got 15, but this is negative 15. So then I said, okay, maybe they're dividing it by negative 5. So then what you can do is say 75 divided by negative 5, and it does give you that. You could say 53 divided by negative 5, it does give you that. That's good. 35 divided by negative 5 does give you that. And then 21 divided by negative 5 does give you that. So this sequence is this one divided by 5, or negative 5. So this sequence is this sequence divided by negative 5. So what we can go do is find a formula for this pattern by just taking this one and then dividing it by minus 5. So we can just say that it's going to be 2n squared divided by minus 5 minus 28n divided by minus 5 plus 101 divided by minus 5. So we can then go simplify to become minus 2 over 5n squared. This negative and this negative will become a positive, like that. And then this positive and this negative is a negative. So that would be negative 101 over 5. Now, this is a parabola, okay? The reason I say that is that it has that n squared. Yes, normally it's an x squared, but with patterns we use n instead of x. So to find, and it's got a negative, so it's a sad parabola, so it makes sense that it has a maximum value. So to find the maximum of a parabola, use minus b over 2a. So we could say n is equal to minus b over 2a. So that's going to be equal to minus, and then b is this one, so it's 28 over 5 over 2 times a, which is negative 2/5. There we go. And so if you had to go type this on your calculator, you're going to end up with 7. Now that is not the answer. If you think about a parabola, you've got the x values, or in this case you'll have the n values, and what they're just telling you there, maybe this is n equals to 1, n equals to 2, 3, 4, 5, 6, 7. Okay, that doesn't look so good. They're telling you that when n is 7, that is where the maximum is, but that's not the maximum value. To find the actual value, you're going to go plug that 7 into the formula in the place of n to see what the actual maximum value becomes, okay? So we could find 7th term. Okay, and if you had to go work this all out, you end up with the final answer of negative 3 over 5. So that is the final answer there. Consider the following geometric sequence. First question says, calculate the 10th term. Okay, so this is a geometric sequence. So if we look on our formula sheet, geometric would be this one. And then if they ever talk about the sum, then we would use this one over here. So we're going to probably just use this formula for now. And so if we go write that down, it was Tn equals to a r to the power of n minus 1. And so they want the 10th term. So we can find term 10. So a is always term number 1. R is the ratio. So you could say term 2 divided by term 1, and that's going to be 256 divided by 1024. And if you work that out, you end up with a quarter. So that is R. So we could say R is a quarter, and then n is 10, and you could say 10 minus 1. Go ahead, type that all in. And so that's going to give us 1 over 256. Moving on to this question over here. So it's said, now a lot of people, you would look at this question and you'd be like, okay, I get it. Now what do they want us to do? But remember that this is sigma notation. Okay. So what you do with sigma notation is you go find the first 3 terms. So to find term number 1, you start with whatever this number is, which is a 0, and you go plug that in, okay? A lot of people think, oh, does that mean term 0? No, it doesn't. So to find term 1, you start with this number. So that's going to be 256, and then 4 to the power of 1 minus 0. And if you had to work that out, and that's going to be 1024. Then to find term 2, you just increase this number by 1, okay? So that's going to be 256, and then 4, and then 1 minus 1, because that now becomes a 1, okay? And if you had to go work that out, you'd end up with 256. Then you go find term 3, and to do that, you just increase that number once more. So this number would now be a 2. So you'll say 1 minus 2. And if you had to work that out, and then that'll give you 64. Okay, so once you have the first 3 terms, then what I want you to do is look at these numbers and try to figure out what type of pattern is this. Well, if you look carefully, it's actually just the same pattern as this one over here, so we know it's geometric, okay? So we know that it is geometric. Now, the next thing you need to remember is that this funny symbol, which stands for sigma, is actually just a funny symbol that actually just means the sum of. So we're going to now go find the formula that gives us the sum of for a geometric. And so on the formula sheet, the formula for the sum of a geometric is this one over here. Okay. And so if we just go write that down, that's going to be a, and then in brackets Rn, and then minus 1, and then R minus 1 at the bottom. So now where a lot of learners make mistakes is for the value of n, okay, which is the number of terms, they just say, oh, it's this number over here. But it's not that number over there unless this number was a 1. So the formula that you should rather use is you always take the top number, then minus the bottom number, okay, and then say plus 1. So it's this number minus this number, and then plus 1. That is the number of terms. So it's going to be 8, take away 0, plus 1, which is 9. So there are going to be 9 terms in this pattern. So A is always term number 1, which was 1024. R is, you could go work it out by saying term 2 divided by term 1, but it's the same as what we did earlier. So that's just going to be a quarter. Then you're going to say N, which is 9, because there's 9 terms. And then at the bottom, you're going to be left with a quarter, take away 1. And then if you had to go work that out, and you round to 2 decimal places, let's write the answer over here. It's going to be 1365.33 if you round to 2 decimal places. This question says that the first 2 terms of a geometric sequence is that and that. Then it says determine the value of t for which the sequence will converge. Right. So when they ask you where a sequence will converge, you need to remember that that is when the ratio is between -1 and +1. That is just something you must remember. That is what converge means. Now, if I gave you a sequence like 5, 10, 20, 40, and you had to work out the value of r Or you could say term 2 divided by term 1, which would be 10 divided by 5, which is 2. So to work out the ratio, you're just going to say term 2 divided by term 1. So term 2 is this, and then term 1 is this. Okay, so that's how we could work out R. So what I'm then going to do is, let me just go write this all a little bit bigger for us. Okay, and so that's going to be bigger than minus 1 and smaller than 1. So you see what I did there? I just went and said term 2 divided by term 1. Now I know that that is R. And so then you just had R between minus 1 and 1. Okay, so what we can do now, so what I think we should do now is this can be factorized, okay? We can go break this down, and I've got a feeling it's going to cancel in one way or another with this part over here. Okay, so with this part here, you need to know, how do we factorize a cubic? So a cubic expression has something to the power of 3. Now in grade like 9, 10, 11, you might have tried to use grouping, where you would maybe group the first two terms and the second two terms. There's nothing wrong with that, but not all cubics can be grouped. So in this one, you cannot group it, because even if you did, there wouldn't be a common factor in the two groups that you do. So we now need to think about how to factorize a cubic, and you typically get taught this in calculus, or at least in the remainder and factor theorem, where your teacher will show you how to factorize a cubic, and sometimes that requires synthetic division. Some learners call that block division. And then there's also another method that I always show learners, which is the method where you have to guess the first term. You know that method where you guess the first term, and then you've got this bracket that is like ax squared plus bx plus c, right? So there's so many different types of ways that we could do this. So you must do whatever method your teacher has showed you, or whatever method you are comfortable with. But of course, we should all end up with the same factorized cubic at the end of the day. So no matter what method you choose, the first part is the same for all techniques, and that is, find a number that you can plug into this expression until it gives you a 0. So for example, if we let t equal to minus 1, go plug minus 1 into the place of t, and then we hope that we end up with a 0. And so if you go work that out, you don't end up with 0, so it's not going to be that one, okay? If you're interested, this one gives you 8. Okay, so now something that is also quite interesting is the numbers that you should plug into this formula should only be factors of 27. So what are the factors of 27? 1, 27. 2 doesn't work, so don't waste your time with 2. 9. And that's about it. You can also use the negatives of these numbers. So you can use plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27. I would typically stick to the smaller numbers. So let's try let's try negative 3. Okay? So we're going to try negative 3 next. Perfect. That gives us a 0. So remember that if the number negative 3 is a factor, then when you turn that into a bracket, you're going to turn it into, so let's actually make some space for ourselves here. So if we have t cubed plus 9t squared plus 27t plus 27, then if you plug in negative 3, then in the brackets, that would be bracketed as t plus 3, okay? And then we're going to be left with some type of trinomial, which there are many different ways that learners have learned how to do, okay? One of the methods is where you have like some type of trinomial here, like ax squared plus bx plus c, and then you need to go find a, b, and c. Another popular method is synthetic division, or some learners call that the block method. I change up my strategy. Sometimes I use the block method, sometimes I use the ABC method. All of them should give us the same answer. For today, I feel like doing the block method or synthetic division. So the way that works is you take this, you take this number that we used over here, which is negative 3, okay, and you go put it over there. Let's write it over here instead. And then you put like some type of block, and then you just take the beginning number or the coefficients of all of those. So what do I mean? It's going to be 1 for the t3, 9 for the t squared, 27 for the t, and 27 for just the normal part. Then what you do is you carry this down, and by the way, this is only going to make sense to you if you have done synthetic division, or which is sometimes also called the block method. If you haven't, then and you use the ax squared plus bx plus c method, well then you're going to have to go try that one so long by yourself, and let's see that we all get to the same answer. Okay, or the same part in here. What you then do is you multiply these two numbers together, that is -3, and then you're just going to add these two together, so 9 plus -3 is going to give you 6, and then you just start the process all over again. So you multiply these two numbers now, and that's -18. You then add these two together, which would give us 9. You then multiply these two together, which is -27. You add these two together, and you get 0. These three numbers are now going to be, well, let me explain carefully. So we know that this one was a t cubed, this one was t squared, you know, the 9. The 27 was a t, and then this one was just a normal, this 27 was just a normal 27. What you then do is you drop the coefficient of each of those. So for example, now you're going to end up with t squared, and then a t, and then a normal. And then there's no negatives that we can see over here, so it's going to all be positive, so it'll become a plus and a plus. So what that means is t squared plus 6t plus 9. That is what you are going to put over here, t squared plus 6t plus 9. Okay? And so what I'm now going to do is I'm just going to take this and go replace all of this with that. So that becomes t plus 3. And then t squared plus 6t plus 9. Okay, now I'm going to take out, I can see there's a similarity over here, but it's not exactly the same. So at the bottom here, we can take out a negative as a common factor. Okay, so I'm going to take out a negative as a common factor. So then that would leave you with t squared plus 6t plus 9. Okay, I'm just going to replace that over here now. So negative and then t squared plus 6t plus 9. All right, now what we have is we have a fraction divided by, you can think of this as another fraction by just saying over 1. Now, what do you do when you have a fraction divided by a fraction? Well, for example, if you have like 3 over 5 divided by 7 over 2, then that becomes 3 over 5 multiply, and then you turn this one upside down, right? So it becomes 2 over 7. So we're going to do the exact same thing over here. We are going to turn it into a multiply. So we're going to be left with, okay, and then you're going to say multiply, and then it's going to be 1 over, then there's that negative, and then t squared plus 6t plus 9, and then that's smaller than 1. Now what we can realize is that this part here and this part here, and so we can cancel those two parts out because they are exactly the same. And so what we now have is that. So you see how we still have the t plus 3, okay? And then we still had the 2 at the bottom, and then we still had a 1 over here, which is this one, and then we still had a negative. So I just made it a -1. So what I'm going to do now is just multiply the two bottoms together. So that'll just give us -2. And then, I mean, t plus 3 times 1, that's just going to be t plus 3. So this is what we now have, t plus 3 over -2. Now, if you multiply or divide, so let's say you have an inequality and it's like -3x equals to 6. Sorry, -3x smaller than 6. As soon as you divide with a negative number, then this sign changes. But it's also true that if you multiply with a negative number to the other side, then the sign also changes. So what I'm going to do here is I'm going to multiply this -2 to that side and to that side, okay? So that's going to become +2. But then the sign changes because whenever you multiply with a negative, or if you divide with a negative and you have an inequality, then the signs change. See how I changed that sign to that side, and then I'm multiplying the -2 to there to become -2. Now we just take the 3 to the right and we take it to the left, and what that then means is that we end up with t is greater than -5, but smaller than -1, because I took this plus 3 over to the other side, so it became 2 minus 3, which is -1. And so this would be our final answer. This question gives us the graph of g of x, which is equal to that expression over there, and they tell us that it passes through the point -2 and 10. The first question says calculate the value of a. So what you can do here is just take this and plug it into the place of x, and then take this and plug it into the place of y. So you end up with 10 equals a we don't know, x is going to be -2, and then plus 7. And so now what we can do is just take the 7 to the left-hand side, so that'll give you 3. I'm just going to type this on the calculator so long. And that gives us 9, so I'm just going to say 9a. We then divide both sides by 9, and we end up with not 3, but 1 over 3, because it's going to be 3 divided by 9. So a would be 1 over 3. This question says calculate the coordinates of the y-intercept. To find the y-intercept of any graph, you make x 0. So let's just go write out our equation. G of x equals to a, which is a third. And then this is a third to the x plus 7. So to find the y-intercept, you make x 0. So let's do that. And if you had to go work that out, you end up with a fraction of 22 over 3. So now don't just stop there. They said find the coordinates of the y-intercept, so that you'll say the coordinates will be x is 0 and y is 22 over 3. This question says consider the graph of h of x, which is now equal to that, and they say describe the translation. Translation means where did you move left and right, and where did you move up and down to go from g to h. Okay, so let's quickly write out G's equation. So G is, well, let's write it down here actually. So G is a third, because that was the value of a. Then there's another third to the power of x plus 7. Now, I want to show you something quite interesting over here. You see that these two have the same base, okay? So for example, what would you do here? X to the 3 multiplied by x to the 4. What would that give you? Well, you would add these two numbers together, and that would become x to the 7. So here, this one is the same as this one. So what could we do with their exponents? Because this one does have a little 1 there, remember? So what would what could you do? Well, you could change this to a third. Don't multiply these two numbers to become 1 over 9. Because look what you did here. You didn't change. You never changed the base. You see how it stays the same? So in the same way, you're going to keep that as a third. And then you're going to add these exponents, which will become 1 plus x, or x plus 1 if you want, x plus 1, and then plus 7. Okay, so let's write that a little bit bigger. So g of x is actually a third to the power of x plus 1 plus 7. Now, how would you take this graph over here? What would you do to that graph in order to turn it into h of x, which is just equal to let's write that down here rather. H of x, which is just equal to a third to the power of x. What would you do? Well, you would need to put a little -1 over here so that that part cancels out. And you would need to put a -7 over here so that that part cancels out. So ask yourself, what did we just do? Well, if you put a -1 next to a x, like if you say x minus 1, that moves the graph either left or right. Can you remember which one it is? Or if you have x minus 1, that moves the graph one place to the right. Because remember, when you're dealing with x's, it's opposite. So negative means, a minus means right, and a plus means left. Okay, so let's write that down. We moved 1, so we say move 1 to the right. And then what are we doing here? Well, here you are moving 7 units down, and 7 units down. Okay, that's the answer. This question says, determine the equation of the inverse of h. Okay, so we know that h is a third x. Okay, I like to, when I do inverses, I change it to a y. Right, now first step with inverse is, remember, you switch x and y around. There we go. And then you need to get the y value by itself again. So remember, this is a exponential equation, so we're going to actually convert that into a log. So we're going to get the y by itself, so we're going to say y equals, then you're going to say log. Now the thing that was with this exponent, so that means the 1 over 3, that becomes the little base over here, and then whatever's on the other side, you're just going to put that over there. Okay, so I trust that by now you have a fairly good understanding of how to switch between exponentials and logs. If not, it's okay. I mean, I've seen this with a lot of learners. It can be weird, okay? But this is going to be our final answer, and you should have expected it to be a log. Why? Because this is an exponential equation, right? Whenever you have an exponent with an x, that's an exponential equation, and the opposite or the inverse of an exponential is a log. And so there we have a log equation. So in this question, they give us this expression over here. Now you need to identify that that is a hyperbola. And then they give us this information over here. So they give us the domain, the x-intercept, and the y-intercept. Okay, so the first question, and I will split these up onto different pages, by the way, but these are just all the questions that we will do. So let's start with the first question. It says, show that the equation of g is this over here. Okay, so, right, I've seen many of these types of questions before. So here's an x and y axis, okay? Now they're saying that the domain of this hyperbola is anything except -2. So we go to -2 and then just put a dotted line through that. What that means is that's your vertical asymptote, okay? At x equals to -2. We then have an x-intercept at 1 and 0, so that would be over here. Okay, that is k, and that is at 1 and 0. We have a y-intercept at 0, -half, which would be there. Okay, so now we don't know the horizontal asymptote, so we don't know if there's maybe going to be a dotted line there, or maybe there. We don't know that, okay? But what we can do is, with a hyperbola, this part here will tell you where the vertical asymptote is. So for example, if it says y equals to a over x take away 3, then that means the graph has moved 3 places to the right. And so if it was like that, you would have a vertical asymptote at x equals to 3. Okay, let me show you a few more examples. Let's say, for example, you had y equals to a over x plus 1. Then that means the graph has moved 1 place to the left. And so your vertical asymptote would then be at 1 place to the left, which would actually be where x is equal to -1. So you got to try to think about, because we have a vertical asymptote at -2, you got to try to think about what this could be. Well done if you realize that that means we would then have y equals to x plus 2 at the bottom, not x minus 2, x plus 2, because that means the graph has moved 2 places to the left. And we can see here we've got a vertical asymptote that is 2 places to the left. A nice way to do it is, if you take this denominator and you make it equal to 0, then look what you get. X equals to -2. Okay? All right, so we have that, and we can say plus q. Now, what I think we can do next is we could possibly substitute this x-intercept into the equation. So this x-intercept is 1 for x and 0 for y. Okay, if I simplify, that'll be a over 3 plus q. Nothing you can do there because you've got 2 unknowns, a and a q, but many of you have probably realized we can just go repeat that now by using the y-intercept. And so we could say, so you could plug y as -1/2, and then I'm plugging it into here, by the way, and then x is 0. You see it says that there's a 0 plus 2 plus q. Then I'm just going to 0 plus 2, if you don't mind, I'm just going to change that to a 2. And there we go. We now have 2 equations. This is the first one. This is the second one. You guessed it, simultaneous equations. Okay, I don't think we're going to need the graph, to be honest. Maybe we might need it a bit later. but for now I need a bit more space. Okay, so what I'm going to do is I'm going to call this equation number 1, I'll call this equation number 2, and I'm going to quickly take equation number 1 and just get this q by itself. So if you follow along, what would happen is that I'm going to take this over to the left. So we're going to end up with negative a over 3. And then we'll just call that equation number 3. I'm then going to take that equation number 3 and I'm going to substitute it into equation number 2. Okay, so that means that if q is equal to negative a over 3, then I'm going to replace this q with negative a over 3. So that's going to leave us with negative 1 over 2 equals to a over 2 plus, actually minus a over 3. Okay, then you see we got fractions over here, so we're going to get a common denominator. A common denominator of those numbers would just be 6. So a lowest common denominator would be 6. That means I'm going to multiply this one by 3. What you do to the bottom, you do to the top. I'm going to multiply this one by 3 as well. What you do to the bottom, you do to the top. And then I'm going to multiply this one by 2 and this one by 2. And so now you end up with negative 3 over 6 equals to 3a over 6 minus 2a over 6. Now when you have an equation and all the denominators are the same, you can ignore them. And so you now end up with negative 3 equals to 3a take away 2a. So negative 3 is equal to 3a take away 2a is a. So there we have our answer for a. Now we can just plug that back into here and we can end up with our answer for q. So q would then be negative a, which is a is negative 3 over 3, and so q is 1. Now we can go plug our a into there and our q into there. And so we end up with y equals to negative 3 over x plus 2 and plus 1. And that is exactly what they have over here. So well done, guys. Now the question carries on. So now the next part says, write down the range. Okay, so if we look at any hyperbola, okay, let's say it's got a dotted line here. How do we know that it's there? Because you make this equal to 0. And you end up with x equal to negative 2, and so that is a vertical asymptote. What does this do to a graph? Does that move it up? Does it move it down? Well done if you remember that it moves it up. So that means we have a horizontal asymptote over here at 1. So check this out, guys. If you ever want to look at the domain, then that's all the x values. So see if you can go from this side all the way to this side. Is it possible to do that without lifting up your pen? Well, let's try. No. Oop, there, we can't cross that line. We have to jump over, and then we can carry on. What that means is that the domain, which is the x values, can be absolutely any number except for over here we had to jump. So x is not allowed to be equal to negative 2. And that's exactly what they said here. Now, it works the same for the range, which is really awesome. Is that, let's say, for example, you wanted to go from bottom to top or top to bottom. Let's see if we can. No. Oh, there's a dotted line, so we have to jump over, and then we carry on going this way. So what that means is that y could be any number except for this horizontal line over here, which we had to jump over. So y is not allowed to be equal to 1. And so that is the range, okay? And you can do this technique for any hyperbola. Let's move on to the next part. So this question says, determine the equation of h, which is the axis of symmetry of g. Okay, so let's hold up over there. We know that if you have a hyperbola, and for example, so like let's say you've got asymptotes over there and over there, we've got these equations of symmetry for any hyperbola that goes through there and then it goes through there. Okay, now remember that this one over here has a positive gradient, and that gradient will always be equal to positive 1. So we can just say 1x plus c. And then this one always has the negative gradient, and it's always going to be negative 1. So that's y equals to negative 1x plus c. Then to find the equation of symmetry, what we normally do is we just take this point over here where the two dotted lines, where these two dotted asymptotes, where they intersect each other, we use that value to then find the value of c on each of those equations. Okay, so let's see what they're saying here. They're saying determine the equation of H, which is the axis of symmetry of G, in the form where M is bigger than 0. So what they're saying there is that M is positive. So they're talking about this line over here, the one with the positive gradient. So we can then say y is equal to 1x plus c. We don't have to say mx because we know the gradient is positive 1. Okay, now this is just a little made up drawing. But if we actually had to go and draw our one, from this part here, we know that the dotted line is here at -2, so x equals to -2. And then from this one, we know that the y value is equal to positive 1. Okay, so if you had to look at this point over here, its x value is -2 and its y value is positive 1. And so we can use that, because remember those those symmetry lines are going to go through that point. So we can use that and substitute it into here. So that's -2 and 1. Okay, so now this 1 is a y value. So we go like that. And then the x is -2 plus c. And then you're going to end up with this. And then if you had to take the -2 over, you end up with c as 3. And so the answer would be y equals to 1x plus 3. You can also just call it x plus 3. You don't have to say the 1. This question says, write down the coordinates of k with a little line over here, which is the image of k. Now, what is k? K was the x-intercept reflected over h. What is h? H is the equation of the line that we worked out in the previous question. So let's make a little graph for ourselves. Because I don't know how you can do this for only 2 marks. The way that I'm going to show you is a little bit more detailed, but I feel that it will help you to understand exactly how we do this. I don't know how they only do it for 2 marks. Maybe there is some fancy way that I'm not seeing, but I'll show you the way I would do this, and it wouldn't only be worth 2 marks. It would probably be worth like 4, but just check it out. So we're going to draw a graph just so I can explain this nicely to you. Now, we know that the original graph, the hyperbola, has a asymptote here at -2. I'm not going to draw the whole graph, and then we have this other asymptote at 1. Okay. Then we had the symmetry lines, which we know go through here. So one of them would go there. And I'm actually just going to draw that one. Of course, there's another one that goes that way, or it would have gone through there, but we don't need that one. So this was the equation of h that we worked out in the previous question. And what we found was that that line's equation is y equals to x plus 3. Now, we've got this point k, which is at 1 and 0, which is over here. Now that is k. Now what they want you to do is they want the coordinates of this point after you reflect it across this line. Okay? So you're going to be reflecting it across that line so that this distance up to there is the same as this distance up to there. Okay, you see, so it's actually a fairly complex kind of scenario. So the way that I would do it, okay, is when you reflect something, you always have to reflect it at 90 degrees to the line of reflection, okay? So for example, if that point was over here, then 90 degrees would be like that and like that. It always has to go at 90 degrees. Do you understand? So 90 degrees. Okay, what you don't want to do is go at an angle, like for example, like there and then there. You have to hit the reflection line, which is this one, at 90 degrees. So what we can do then is just draw a 90-degree line. Okay, I don't know where it's going to go. It might end up going there. I don't know because I haven't drawn this according to scale, but it doesn't matter because the mathematics or the maths is going to work out. So there's a 90-degree line. What I would then do is quickly find the equation of this line. It's not going to be difficult to do. The reason is that this line here, what is the gradient of that line? Can you remember? Well, it's 1, remember? So what is 90 degrees of that? What would the line that is So you know when two lines are perpendicular, right? Or 90 degrees. When you multiply their gradients, it always equals -1. We know that. So if I take the gradient of the first line, which is a 1, okay, and I multiply it by the gradient of this other line, which I don't know, which is this line over here, then if you had to go work it out, you'd see that the gradient of this line, which was this one over here, is -1. So we can say y equals to -1x plus c. Then to find the value of c, we can just plug in any point that is on this line. Can you see one? Whoa, this one over here, k itself. So we can go plug in 0 and 1 for the x. And if you had to work out c, you're going to end up with 1. So y equals to -1x plus 1. Okay, so that means it's actually going directly through here. So like that. Okay, so now we have the equation of the green line and the blue line. Here's the blue line, and here's the green line. Okay, so I would like to now find out what is this point over here. What is its coordinates? Well, to do that, to find the point where two lines cross, you make their equations equal. So you could say x plus 3 equals to -x plus 1. Now you just solve for x, so you bring this one over. You can bring this one to the other side, so it'll become 1 minus 3, which is -2. Let me just slow that down a bit. Kevin, you're going too fast. There we go. And then 2x equals to -2. Divide by 2, x is -1. Okay, so these 2 points, or this point here, the x value is -1. To find the y value, you can just plug that x value either into this equation over here or this equation over here. It does not make a difference. I'm going to plug it into this one over here. So y would be, so x is -1 plus 3, and so y is 2. Okay, so we now know that this point over here is -1 and 2. So we could use the midpoint theorem now in reverse. Because if you think about it, we're trying to find this coordinate over here, which is called k prime. But we know that it's going to have an x and it's going to have a y. Now we know that if you look from here to here, this is the midpoint. Okay, so we could use the midpoint formula, which is x1 plus x2 over 2 and y1 plus y2 over 2. So how would you normally do the midpoint? Well, you would normally take this x value and you would plus it with this x value. You would divide that by 2 and you would get your answer. But we already know what the x answer is for the midpoint. It's -1, so we can make that equal to -1. Now, if you had to solve this equation for x, you would take this 2 to the other side where you would multiply it, so it would become -2. Then take this 1 over and you'd end up with x equals to -3. So this x value here is -3. I know it's more than 2 marks. I just cannot think of a nice, easy way to do that. And then, okay, so now to find the y value, we do the same. So you would take this y value and you would plus it with this y value. You would divide that by 2 and you would get your answer. But we know the answer is 2. So then you can take this 2 to the other side and you end up with 4, because 2 times 2 is 4. And then you're just going to end up with y equals to 4. And so there we have the answer. So the coordinates of k with a little line would be -3 and 4. For this question, here are all the questions that we are going to be doing, but I will split them up onto individual pages just so that it's easier for us to work with. Okay, so let's begin. We are told that the sketch below shows this graph over here, and C is the y-intercept, A and B are the x-intercepts, and D is a random point on the graph. First question for 3 marks, calculate the coordinates of E, which is the turning point. Okay, 2 ways to do that. Well, 3 if you are in grade 12. If you're in grade 12, I'm not going to go through that method, but it's just using calculus. You know, take the first derivative, make it equal to 0. I'm just going to use the normal grade 11 techniques, of which there are 2 different ones that you could use. The best one is negative b over 2a. You know that's the x. That's how you find the x value of a turning point, negative b over 2a. The other way that some learners, maybe 10% of learners enjoy this method, I don't know why, but it's okay, is you would use completing the square. Some learners like to do that. You're more than welcome to, but I don't enjoy completing the square. I just use this one over here. Okay, so the x value of the turning point is negative b, so we say negative, and then what is b? B is negative 6 over 2. Now what is a? A is this number over here, which is negative 1. Okay, and if we had to go work this all out, you're going to end up with 6 over negative 2, which is equal to negative 3. That's the x value. Then to find the y value is you just take that x value and you put it into the place of x. And remember, a lot of learners mess up over here. This negative x, you must do it like this. You must put a negative, then you put the x value, and then you square. Okay? What some learners do is they put this negative in the bracket, and then they square. That's not what we're doing. So the negative is by itself, okay? It's not with the x, it's in front of the x. So you're going to say negative, then you open up your bracket and put the x value in, okay? Minus 6, x is negative 3, plus 7. If you work that out, you end up with 16. So then the coordinates of E will be x of negative 3 and y of 16. Okay, let's just put that a little bit better. There we go. This question says, write down the value of k. Well, what we do is you just take this point and you take this equation and you tell this equation that the x value is negative 5. So the x value is negative 5. Okay, see how I kept the negative on the outside like that. And then if you just go type this all in, you end up with 12. So the value of k is 12. So let's just go write out everything that we have, negative 3 and 16, and then we know that this k value was 12. Okay, so with this question it says, determine the equation of the straight line that passes through C and D. Okay, so this should be a fairly straightforward question. We know the coordinates of D. We can easily get the coordinates of C. Why? Because C is the y-intercept, and to find a y-intercept, what do? Well done. You make x equal to 0. And so it's going to be y equals to negative 0 squared, take away 6 times 0 plus 7, and that's just going to give you 7. So the coordinates of C then will have an x value of 0 and a y value of 7. Okay, so now we can easily go and work out the equation between these two lines, or these 2 points, because we know that a straight line is y equals to mx plus c. Now, to find the gradient, you could use the formula y2 minus y1 over x2 take away x1, and so you could say 7 take away 12 over 0 take away negative 5. If you had to go work this out, you end up with negative 1. And so now we can say that y is equal to negative 1x plus c. Then to find c, you either plug in this point or you plug in this point. I'm just going to choose this one over here. And so you're going to say 7 for the y, 0 for the x, like that, plus c. And so you end up with 7 is equal to c. And so now your final answer for that equation would be y equals to negative 1x plus 7. You could also just say negative x if you wanted to. That's also fine. This question says that we have a tangent, okay, which is parallel to CD. So this was CD. Whoops, let's do that again. And then we have a tangent, so which is parallel. So remember, a tangent only touches the parabola once, but it's parallel. So parallel could go like that. You know, parallel lines, right? So it's not going to be one of these lines because these are touching the graph twice. Can you see that? So it's probably going to be up here, going something like that. I'm not now be careful. This part's really important. No one said that it's going through E, okay? It might just look like it's touching E, but don't take that for granted. It might not be, okay? There's no theory that tells us the tangent has to touch the turning point. Okay, because it could just be touching in the front of here. It's not necessarily going through the turning point. A lot of learners are going to just assume that it is. It might be, but it's not. It doesn't have to be. Okay. So it says that a tangent which is parallel to CD touches F at P. Okay, so it's not going to be at E. It's going to be at P. So let's point there and say that that's P. Determine the coordinates of P. You see, so it's not going to be going through E, okay? Right, so what we're going to do, guys, I love these types of questions. Let me show you what we can do. You are going to, okay, so you know that how do we normally find the place on a graph where the graph and the straight line intersect? Like, what if I asked you, what is these coordinates? What would you do? Well done if you said you would make their equations equal, okay? So we're going to do the same here, because can we all agree that these two are touching, the parabola and the straight line, okay? Now, we don't know the equation of the tangent, but we know that it's a straight line, mx plus c. We do know its gradient. How do we know its gradient? Well, they said that it's parallel to this line, and we know the gradient of this line. Remember, we worked out its equation, y equals to negative 1x plus 7. So this one's gradient is negative 1, and so this one's gradient is also negative 1, because they are parallel. But we don't know the c value, but that's okay for now. Okay, so what we're going to do is you're going to take this equation, and you are going to make it equal to the parabola. Okay, now, take everything to the one side, just like you would normally try to solve. So I'm going to take everything to the left. So we end up with x squared, take away 1x plus 6x, because when this comes over, it becomes a plus. Then plus c minus 7 equals to 0. And so now we end up with x squared plus 5x plus c, take away 7, equals to 0. Now, I would like you to think about the nature of roots. Okay, you know, with nature of roots, you've got all those different options, and nature of roots is all from b squared minus 4ac, the discriminant. So when that is a negative, what does that mean? If you get a negative for that, it means non-real. What that means is that there's no answer. So it means that the straight line tangent is not ever going to be the same as the parabola. What that means is that your graph would look like this. You see that? It never touches. Okay, but that's not what we have. So if the b squared minus 4ac is any number that is 0 or positive, then we say that that is real. Now, inside here, remember there's three different options. You could get rational, irrational, or equal. What does equal mean? Well, that's when your b squared minus 4ac is equal to 0. And what that means is that there is only one answer. One answer. Now remember, we're trying to see where is the tangent going into the parabola. How many answers do we want? Well, if you look carefully, how many times does a tangent go into a parabola? Well, if it's a tangent, it only goes once. If it was a normal straight line, then it would go twice. But specifically, if it's a tangent, it only goes once. So that means that we would like our b squared minus 4ac to be equal to 0. So we're going to take this now and we're going to make the b squared minus 4ac equal to 0. So we could go b squared minus 4ac, and we're going to make that equal to 0. So what is b? Well, b is 5. So we can say 5 squared. A is 1. And what is c? Well, c is not this c. C is all of these parts. It's the parts that don't have x. And so that's going to be c minus 7, and you're going to make that equal to 0. And so now you're going to end up with 25, because that's what 5 squared is. Take away 4, because that's 4 times 1. And then there's a c minus 7, and you make that equal to 0. Then we can just solve for c. So we're going to end up with 25, take away 4c, plus 28 equals to 0. I'm going to take the c over to the other side, or the 4c over to the other side, so we end up with 4c equals to 25 plus 28, which is 53. Then to get c by itself, you would say 53 divided by 4, and so c would be 13.25. Okay. Now that we have C, you got to remember, what is the original part of this question? We're trying to find the coordinates of P, which is where the where the tangent and the parabola intersect. And that we already did over here. We made the two equations equal to each other. Then we went and we simplified it, and then we simplified it a little bit further. So what we can do now is just plug the C value into here. If you wanted to, you could go plug the C value back into here, and then you could restart the question all over again, and you could make their two equations equal. But we've already done that, so we can just go plug C in over here now. And so we could say that 1x squared plus 5x plus C, which is 13.25, take away 7, and now we just simplify. So x squared plus 5x plus 6.25 is equal to 0. Now I'm going to use the quadratic formula over here. I've run out of space, but I'm going to use the quadratic formula, and if you solve that correctly, you should end up with x equals, and we should only get one answer. We shouldn't get two answers, because the tangent and the parabola only touch in one place. There we go. We end up with x equals to negative 2.5. Okay, then to find the y value, because remember, we've just found the x value of P now, which is negative 2.5, which makes sense if that's negative 3. This is a little bit to the right. Then we can just go plug it into either the parabola equation, or we can plug it into the tangent equation. Now, I'm going to plug it into the parabola equation. So x is negative 2.5, so we can say like that. And if we go work this out, we end up with 15.75. And so that would be the coordinates of P. It would be negative 2.5 and 15.75. Now, if there are any grade 12s who are maybe interested in a calculus way of doing this, I'm going to show that now. If you are not interested in the calculus way, then you can skip to the next part. I'm now going to redo question 6.4, but using a grade 12 calculus approach. So only watch this if you maybe didn't understand the... so first of all, if you're a grade 12 learner and you didn't enjoy or you didn't understand the grade 11 method. Okay, so if you're a grade 12 calculus learner, what you could do is... okay, so it says that a tangent, which is parallel to CD. Okay, so a tangent, which is parallel to CD, touches F at point P. Okay, so it would probably go something like that. Wait, it's a tangent. So it only touches once. Okay, there we go. So that would be point P over there. Okay, now, we know that it's parallel to this line, and we found the equation of this line in a previous question. So when two lines are parallel, what do they have in common? Well, they have the same gradient. So then the gradient of this line is negative 1. So what is the gradient of this line? Well, this line is also negative 1. Now, grade 12, what we learn in calculus in grade 12 is that if you have a graph, and you have, oh, it's an ugly graph, so is that, there we go. And if you have a tangent, okay, then what do we know about the tangent and the graph? At that point of contact over there, they have the same gradient. Yep. So we can say that the gradient of the graph, or the parabola, is equal to the gradient of the tangent. Okay, how do we find the gradient of a parabola? Well, that's where grade 12 comes in. That's where we use the first derivative, okay? And the gradient of the tangent, we already know, is negative 1. We already know that the gradient is negative 1, so we can just say negative 1. So what we can then do is we can go find the first derivative, because we have the original parabola. So the first derivative would then be, now I'm just doing first derivative, so negative 2x minus 6. You know how I put the 2 in the front and I did all of that. Okay, so there's that. So we can then say that negative 2x minus 6 is equal to negative 1. Okay, and now we just solve for x. So negative 2x would then be equal to negative 1 plus 6. So negative 2x would be equal to 5. Divide both sides by negative 2, and x would be equal to negative 5 over 2, which is the same as negative 2.5. Okay, so we have the x value of that point. If there's any grade 11s watching this, you're like, oh, can't I use that, sir? I don't know how your teachers... Trust me, just rather stick to the grade 11 method, and then next year when you're in grade 12, then just use this method, okay? I don't know how your teacher's going to take it, and they might actually not be happy with it, because they might not know if you actually understand what you're doing, but you're just copying a technique that you found on the internet from some random dude. Okay, so rather do the calculus method in grade 12, and then for now, just stick to the grade 11 method. Okay, right, now we need to find the y value. So to find the y value, you can just plug this x value into the parabola, and so you would end up with y equals to negative. Now, what is the x value? It's negative 2.5. I'm going to run out of space here. Let's rather do it over here. Okay, and if you had to go work this out, that'll give you 15.75. 15.75. And so the coordinates would then be p would then be negative 2.5 and 15.75. This question says, for which values of x will f of x minus 12 be bigger than 0? Okay, so what I would do is I would just say the original equation, so negative x squared, take away x plus 7, and then I'll just say minus 12, because that's what they're doing here, f of x minus 12, and then I would make that bigger than 0, and that's going to give us negative x squared, take away 6x, negative 5, bigger than 0. Then you could leave it like this, but I don't like having a negative in the front here, so I'm going to divide everything with a negative. But now you got to remember something. When you divide inequality with a negative, or if you multiply an inequality with a negative, the sign has to change. Okay, now this can factorize pretty easily into x plus 5 and x plus 1. Now when it's an inequality, what you don't want to do, so this would be wrong to do this. If you have x plus 5, x plus 1 smaller than 0, what you don't want to do is say x plus 5 smaller than 0 or x plus 1 smaller than 0. That is not correct. I know that that's what you would do if it was an equal sign, but when it's an inequality sign, you don't do it. So what do we do? Well, what you do is you pretend that it's an equal sign. You solve for x, so that would be this and this. So for this one, you would end up with x equals to negative 5, and for this one, you'd end up with x equals to negative 1. And so those are called your critical values. Those are your critical values. So you go put those on your number line. So x's negative 5 would be first, and then negative 1. Okay, now have a look at this part. It's asking you, where is this graph, which is a parabola? Is it a happy or a sad parabola? What do you mean, Kevin? Is it smiling like this, happy, or is it sad, going down? Well, because this x squared term, it depends. If you use this one, then it's a sad parabola. If you use this one, though, then it's a happy parabola. Now, some of you are like, well, dude, doesn't it matter? You can't just choose which equation you want to do. It actually doesn't matter, because if you choose a sad parabola, then it's where the sad parabola is positive. And if you choose a happy parabola, then it's where that is negative. And so it actually just all cancels out, and so you end up with the same answer. Yeah, I'm dropping some important tips here, guys. So we know that this is a happy parabola if I chose that one, so I'd go like this. Now the question says, where is this happy parabola smaller than 0? What does smaller than 0 mean? It means under the graph. So if you could think of this as like the ocean, then when they say smaller than 0, it's everything underneath, okay? So if we highlight this part, that's above and that's above. But if you look at this part, that's below. That's below. So where is it below? Well, it's anywhere between minus 5 and minus 1. So we could say, if you wanted to use interval notation, you could say anywhere between minus 5. I'm using round brackets because they have it as, they're not including anything. So up till minus 1. If you rather wanted to use interval notation, then you could say x is bigger than minus 5, but smaller than minus 1. This question says, how many years will it take for an investment to double in value if it earns interest at 8.5 compounded quarterly? Okay, so we definitely, this is definitely a grade 11 question. So if you are a grade 12 learner watching this right now, don't always assume that a financial maths question is a grade 12 question. Okay, a grade 12 question is when you have someone who, for example, deposits money every single month. This is just a single investment. So how many years will it take for a single investment to double in value? They're not putting in certain amounts of money every single month. Okay, so this is just a grade 12 question using the compound formula. So we don't know what the original value is, and we don't know what the final value is. But we do know that it's going to double. So what we can do is we can let P equal to X. Then what would A be? Then A would be 2x, because they said that A is going to, or the investment is going to double. So we could say 2x equals to x, and then 1 plus I. Now I is 8.5%, so we could say 8.5%, or you could say 0.085. Now, they are compounding quarterly. So if you take a year, which is 12 months, if you compound quarterly, that means you're going to compound every 3 months, like that. Okay, so how many times is that? How many quarters do you see there? Well, there's 4 quarters. So how many times are you going to compound your money per year? 1, 2, 3, 4 times. So put a 4 here, not a 3. It's every 3 months, but that means 4 times per year. And then over here, we don't know. Over here, we normally say 4 multiplied by the number of years. So we'll just say 4 times n. Okay? Now, if we divide both sides by x over here, we would see that those x's would cancel out. Okay? And so we end up with 2 equals to 1 plus 0.085 over 4 to the power of 4n. Now, this is where grade 12s, this is where we would use logs. So to do logs, you take whatever the exponent is and you make it equal to log. Okay, so you take the exponent, you make it equal to log. Then whatever was below the exponent becomes the base. So you're going to put that over here. Okay, whatever's on the other side just becomes this part over here. So go ahead, type that all in on your calculator. Okay, so that's going to give you 32.964. Then to get n by itself, you're going to divide by 4, and that should give you 8.24 years. 8.24 years. So it would take 8.24 years for something to double in value if the interest rate is 8.5% compounded quarterly. These are all the questions that we will be looking at, but of course we don't have any space to write on our screen, so I will split these questions up into individual parts. Okay, but there are all the questions that we're going to be doing. Okay, so let's begin. So a company purchased machinery for 500,000 Rand. After 5 years, the machinery was sold for 180,000 Rand. Of course, machinery becomes less, it's worth less because you use it, it gets a little bit damaged, you know, like a car. If you buy a car, you use the car, when you try to sell the car, you're going to sell it for less than what you paid for it. Okay? And after they sold it, new machinery was bought. So let me quickly explain and give you guys some study tips right here. Not study tips, some knowledge about how these questions work. Okay, because you're gonna get them. So the way it works in real life is the following. Let's say you have a car. Okay, here's your car. Wow, that's a terrible. Okay, it doesn't matter. This is a car. Okay, and this car is currently worth 200,000 Rand. And you've just purchased this car brand new in the year 2023. Okay. What will happen to the value of your car over the next 5 years? So in 2028, when you try to sell your car, are you going to sell it for more than 200,000 or less? Much less. Probably, typically it'll depreciate by 40%. Let's say it'll be worth 120,000. Okay, that's your car. And it's now your old car. Okay, so You see, that's that. Now, why did the car become less? Well, it's called depreciation. Right. Now, let's take the same car. Okay, let's say this is a Okay, let's just say it's a brand new VW Polo. Okay, we all know that car. So let's just say it's a brand new VW Polo. I'm not saying that's the price. Don't quote me on that. I'm just using random examples. Now, if you want to buy a brand new VW Polo in 2028, okay, is it going to be more than 200,000 Rand or is it going to be less? Remember, I'm talking about a brand new VW Polo. Because remember what happens is this person's going to drive their car for 5 years, then they're going to sell it, and then they're going to buy a brand new VW Polo in 2028. Well, it's going to be worth more. So let's say this one's going to be worth 300,000 Rand. Okay? Why did the price increase from there to there? That's called inflation. Okay. So now think about this. What if this guy in 2023 was intelligent about how he invests his money? What if he realizes that this person realizes that they're going to sell their old car for 120,000 Rand and then they're going to buy their new car for 300,000 Rand? So how much money will they actually need out of their own money, if you think about that carefully? They're going to buy the new car for 300,000, but they're going to sell their old car for 120,000. So, what is 300,000? Take away 120,000. Well, that's 180,000 Rand. That is the amount of money that this person will need in 2028. Okay, now think about this carefully. What if this guy in 2023 decides to open up some type of investment account, and he tells the people at the investment, hey guys, hope you're well. In 5 years' time, I need to please have 180,000 Rand. So, how much money must I give you now in 2023 so that by the time it gets to 2028, it would have grown to 180,000. And they're going to do their little calculations. They're going to assume a certain rate of growth. And they'll tell them, okay, you can give us 130,000 Rand today. And then we will let that money grow over the next 5 years so that by the time it gets to 2028, it'll be worth 180,000 Rand. This type of thing over here is called a sinking fund. And this is what businesses all over the world do. They know that in 5 years' time, they're going to have to sell their old equipment. They're going to have to buy new equipment. And so they know that they're going to need 180,000 Rand. But instead of saving up 180,000 Rand, they rather invest a lower amount and then they let that grow on the stock market, for example, so that by the time it gets to 5 years, it'll be worth 180,000 Rand. Does that make sense? That's what's happening in these questions, okay? So your equipment becomes less, that's called depreciation. To buy new equipment, it's going to be more, that's called inflation, okay? And so that's typically what these questions are going to ask us. They're first going to ask us the depreciation question, then they're going to ask us the inflation question, then they're going to ask us the sinking fund question. It's always the same. Here's some more knowledge for you guys. When it's depreciation, use this formula. It's the grade 11 formula with a minus. When it's inflation question, use the same formula with a plus. That's the typical grade 11 and compound formula. Okay, that's how it always works. And these values here are always going to be per year. They're not going to be compounded monthly, quarterly, nothing like that. Inflation and depreciation are just per year. So it says here, calculate the rate of depreciation over the 5 years. Okay, so we're going to use this formula. So we know that the final, now some learners are going to switch these two values around by mistake. Remember that this is the start and this is the ending or the finish. So if you think about this carefully, the starting price was 500,000, but then the machinery became 180,000. So this is the ending price. So you're going to put the 180 over here, okay? If you put the 500 here, that's because you're thinking that the bigger number must always go here. That's not always true, okay? That's only true if your money's going up and not down. Okay, and then this would be 500,000. 1 minus. Now, the interest rate is what we are trying to calculate. That's your rate of depreciation. The number of years is 5. There we go. Now, to calculate this, you're going to first divide by 500,000. So you're going to end up with that. We're not going to use logs. When there's a number over here, we just need to take the fifth root on both sides. 5, 5. Okay? Now, don't type this on the calculator just yet. It's going to give you a whole bunch of decimals. Rather just leave that for now. And so what we're going to end up with is, okay, I'm just going to write over here. I'm running out of space. So we're going to end up with that and that. And then on the right-hand side, which is this side, this 5 cancels out that 5. So what we have on the right is just 1 minus I. Okay, now you can do different things here. You could take the I to the left if you wanted to, and then bring this to the right. But what I'm going to do is I'm just going to take this 1 over. So we're going to end up with the following. So 180,000 over 500,000. Take away 1. This 1 is not inside the square root. Just be careful. And then on this side, you have negative I. Okay, go ahead, type this on the calculator now, but don't round off. And remember that that minus 1 is not inside the square root, okay? And so if you did this correctly, you should end up with negative 0.184806. That's enough. And then equals to negative I. We can now drop the negatives on both sides and then multiply by 100 because we need to turn this into a percentage. The rate of depreciation is always a percentage. And so you're going to multiply this with 100. And so your value should be 18.48%. Okay, now this next part is the inflation part. So they said the rate of inflation is going to be 6.3% over the 5 years. What will the new machinery cost? Okay, so remember inflation, we use this formula now. Okay, so think about this. The starting price of the equipment is not the 180,000. That's after the depreciation. What we're going to do is we're going to say 500,000. Okay, we're going to see what does that 500,000 become if the interest rate is 6.3%, which is 0.063 over 5 years. And so if you had to go work that out, you'd end up with 678,635.11. And if you're confused why we didn't use 180,000 here, then you need to just rewind and go to my example where I showed you the person who was buying the new car, and you would see that the inflation amount was always based on the brand new car, which was the 200,000. I didn't use the price of the old car. Okay, right. So think about this. In the previous question, we know that the equipment becomes 180,000 after 5 years. And the price of the new equipment becomes that. So you can think about what's going to happen next in the next part of the question. So here they say that the company, now let's just quickly write that down. So the old equipment is going to be 180,000. Remember when I did the example with the car, that became 120,000. And then what is the new equipment going to be? Well, that's the value that we just calculated, which was 678,000. And then 635.11. So the company sets up a sinking fund and made the first payment into this fund on the day the old machinery was bought. On the day the old machinery was bought, okay, on the day that the old machinery was bought. The last payment was made 3 months before the new machinery was purchased. The interest earned on the sinking fund is that. Compounded monthly. Yeah, when you have a sinking fund, then they can do it monthly. The money from the sinking fund and the 180 from the sale that was used to pay for the new machinery, calculate the monthly payment into the sinking fund. This is an excellent question, by the way. They've added in a few little twists here. So This is a very, very good question. Okay, so when we do a sinking fund, it's usually going to be like a monthly payment, okay? And it's always going to be some type of investment. You invest into your sinking fund. Remember when I showed you the example with the person with the car? They told him, I showed you at this part of the screen, they said that he or she's going to have to put 130,000 Rand in, and then it should invest up until 180,000. So it's an investment, okay? Now, they're going to be paying every single month, so that's definitely a grade 12 type of question. And think about this. Do we want the money now? Like, when does the company open up the investment? They said that the company sets up a sinking fund and they make the first payment on the day that the old machinery was bought. You know, when they purchased that old machinery for 500,000. So that was okay. So that's when they opened the investment. Now, when do they want the money? Do they want the money immediately, or do they want the money in the future? Do they want the money in the 5 years' time, when the machinery becomes old and then they sell it again? Exactly, right? That's when they want the money. They want it in 5 years' time, so they want it in the future. Okay, so we're going to use the future value formula. You know, the one that goes like this. Okay, because remember, guys, that's when I showed you the example with the car. Remember that the person who purchased the car, when did they ask about the investment? You ask about the investment on the day that you buy the car. And then you know that in 5 years, you're going to have to sell your old car, and then you're going to have to buy the new car. So you're investing for the future. Okay, so it's always going to be a future value formula. Now, there's a couple extra little twists that you need to be extra careful about in these questions, or in this particular question. I've made videos where I explain how to calculate this value. And what we normally do is the following. When we are looking at a monthly investment, when do we normally make the first payment? And when do we normally make the last payment? I'm hoping you guys know this. Well done if you remember that the first payment is normally made after 1 month, and the last payment is usually made on the last day. So on the very last day. On the last day. If that is what they did, then to work out the number of payments, you would take the 5 years and you would multiply that by 12, because that would be 12 months in a year, so that would be 60 payments. That is the normal scenario. However, they did things a little bit differently in this question. They said that the first payment was made on the day that the machinery was bought. And that's also the day that they would have opened up their investment. So they didn't wait for 1 month after they opened up their investment. They literally put the first payment in on the same day that they purchased the machinery. So that's the same day that they opened up their investment. So they made their first payment immediately. So their first payment was not after 1 month, but immediately. So they've made one extra payment. So we're going to say +1 over here. Okay. Then, when was their last payment done? They said that the last payment was made 3 months before the new machinery was purchased. They were supposed to do it on the very last day, but they decided to stop 3 months before. So that means they're going to make 3 less payments than what they normally would have made. So if you had to go calculate this now, that means that they have only made 58 payments. I'll show you this on a number line if you want. Okay, so that's 60 months. Okay, and this is when they open the investment, but you're only supposed to make your first payment over here. That's when you're supposed to make your first payment, and you're supposed to make your last payment over here. Okay, but what they did is they made their first payment over here. So we say they made first payment. They're supposed to do it here, but they did it here. So that's one extra payment because they're going to make one payment there and then they're going to make their next payment there. So they're going to make one extra payment. That's why I said plus 1. Then they are supposed to make their last payment over here, but they stopped 3 months early. So 59, 58, 57. So they made their last payment over here. What that means is that they did not make this one, or this one. So they missed out on those 3 payments, and that's why I did that. So they only make 58 payments. That's the first important thing you need to understand. The next important thing you need to understand, and I have made videos on this in the past, when someone is investing money and they make their last payment over here, for example, their money that they have accumulated up until that point is still going to stay in the bank until the end. They don't take the money out. So that money is still going to be in the bank, and so it's still going to compound for 1, 2, 3 more months. And so if you have watched those videos, or if you've seen this in your textbook, or if your teachers explained it, then that is when you would add another little bracket over here, and you would compound for those 3 months. Okay? And then this number here is going to be a 58, because we're going to make 58 payments. That's how we got that over there. But then the money's still going to be in the account for another 3 months afterwards. Okay, I hope this makes sense. It's a very good question. If you are confused right now, then it means that you need to go first do a bit of studying on certain parts. One of them is how to use the future value formula. The other one is, okay, so you would have to go study this, the future value formula. Just go learn the basics of that. The next thing you need to learn is calculating the value of n. How to calculate the value of n when a person makes early payments or late payments. Okay, that's important. And then the next thing you need to know is how to use the future value when someone stops paying early, stops early. I have videos on every single one of those. Okay, so how to use the future value when someone stops early, because that'll teach you how to do this part. Calculating n is how I calculated the 58, and then how to use this formula in general is the future value. Okay, so most of you probably know this one, okay, but you might need to just go touch up on how to do this part and this part. All right, so let's actually go calculate now. So from this part, it's really easy. We know that the future value, although there is another little thing we need to understand. So how much was the new equipment going to cost? And how much is the old equipment? Remember that they're going to sell the old equipment. So think about this. Think about the guy that I told you about in the beginning where he purchased the car. Remember, this is the amount of money you're going to need for the new equipment, but they're also going to sell the old equipment. So they're not going to need all of this. The amount that they're going to need in the future is going to be 678,635.11, take away 180,000. Okay, so to work that out, I mean, that's pretty straightforward. You just put in your calculator. I don't know why I said that. That is the future value that they need, 498,635.11. So we put that in the place of f. So we're going to say 498,635.11 equals. The monthly payment we don't know. That's x. That's what we're trying to calculate. The interest rate on the sinking fund is 10.25, so I say 1025. It's compounded monthly, so I say over 12. The number of payments we calculated, I'm running out of space. Then we need to put in this next little bracket, which is 1 plus 0.1025 over 12, and that's only for 3 months. Don't say 3 times 12 because that implies 3 years. And then at the bottom here, we're just going to say 0.1025 over 12. Okay. Gotta love grade 12 maths, eh? So what we need to do now is we somehow need to get this x. Okay, so what I would do is I wouldn't use my calculator right now. So I would just multiply this over to the other side, but I wouldn't use the calculator. So what I mean is I would say 498,635.11, and I would multiply that by 0.1025 over 12. So that takes care of that part. Then I would divide by all of that. Okay, so you'd say 1 plus, it's a double bracket, 1 plus 0.1025 over 12, 58, minus 1. And so that's 0.1025 over 12, and then all of that is to the power of 3. Okay, and then I would go take all of that now and just type that on the calculator. Instead of doing all these little parts and having to not round off the decimals, I would just do it like that. And so if you had to go type all of this in on the calculator, your final answer should be 6,510 Rand and 36 cents. Determine the first derivative using first principles. So remember, the first principle formula is this one over here. Okay? So we can say that the first derivative is equal to the limit as h goes to 0, and then you've got this formula f of x plus h minus f of x over h. Okay, now there are a lot of learners who struggle to use this formula. Let me try and make it easy. So you see f of x, so that goes there, you see? And then this part, let me show you how to do that part. So what that part tells you is you must take all of the x's that you see over here. For example, what would you do? Okay, so let's say we have f of x, and that's negative x squared. So what would you say if I said f of 1? Well, you would replace all the x's with 1. If I said f of 2, you would replace all the x's with a 2. So what if I say f of w? Then you would replace all of the x's with a w. So what if I say f of x plus h? Then you must replace all of the x's with x plus h. So like that. And that is what you would put there. Okay, and so let's go write this down. Remember, we have to write this limit as h goes to 0 the whole way down. I know it's annoying, but just got to do it. Okay, so you're going to say negative x plus h. Okay, then you're going to say minus, which is this minus, and then you're just going to put the f of x, which is that. So it's also got a negative. Okay, and then h. There we go. Not too bad, eh? And now we're just going to go simplify as much as possible. So I know that this negative and this negative makes a positive. Now, there's a lot that can go wrong here. I find that this question is actually quite challenging with that negative. So leave this negative alone. Open up 2 brackets because there's a 2 over there. There we go. Okay. And so leave this negative over there. And then go multiply out the 2 brackets. So it'll become x squared plus xh plus xh plus h squared plus x squared. Now in the next step, go put the negative into the bracket. You can also put these two together. So xh plus xh is 2xh. Okay, so that's going to become negative x squared, then negative 2xh, negative h squared plus x squared over h. You've maybe heard me say this before, maybe you haven't, but at this step over here, when you've gotten rid of all of the brackets, everything that does not have an h should cancel at this step. If not, you've made a little mistake, and it's usually this negative where you haven't used it correctly. But have a look here. This doesn't have an h, and this doesn't have an h. And look at that. Negative x squared plus x squared, they cancel. That's good. Everything else that has an h does not cancel. Okay, and so now we go limit as h goes to 0. And so at the top, we're going to have negative xh minus h squared. At the bottom, we have h. Take out h as a common factor at the top. If there is more to take out, don't. Just take out the h. And so you'd be left with negative 2x, take away h. The reason we just take out the h is so that it cancels with this one. So you see they cancel out. Okay, limit h goes to 0. And so now it just gives us negative 2x take away h. At this step, you can let h become 0. Kevin, why can't we let h become 0 in these steps? Because you have a h at the bottom, and you're never allowed to have a 0 at the bottom. But now you've cancelled out the h that's at the bottom, and so you can now just say equals, and then we're going to let the h become 0, and that's going to give us negative 2x, and that is the final answer. If you did this using the FOST method of taking the first derivative, you also get negative 2x. But because they said first principles, and it's for 5 marks, you have to go do this long method. Here they say in this question, determine the first derivative. Remember, that does not mean inverse. Inverse is usually with an, or not usually, it always is. It's got a negative like that, okay? Like that. This is a little line, so that means first derivative. And it's only for 2 marks, and they did not say use first principles, so you don't have to go use the long method. You're just going to use the short method. So you take this 3, multiply it with the 4, which becomes a 12, then it becomes x to the power of 2, and then this 2 multiplies to the front, and that becomes 10, and then x, and that's the answer. Okay, now remember, in this type of question, some of you might look at this and be like, okay, bro, what are they asking? So remember, they can ask you to find the first derivative using 3 main methods. First derivative. They could say, find f of x like that, where they use that little line over there. The second way is that they could say find, for example, dy by dx. And the third one is they could say find dx, and then they use these big square brackets. All 3 of those are asking you to do the same thing. They are just 3 different ways of showing it. Okay, so what we do here first is we can just say equals, and then we first need to go simplify. So while we are simplifying, we just keep saying dx, and we keep this big bracket. Okay, now, whenever you have a situation like this where you've got this one little thing at the bottom, you could either try to factorize at the top here, but there is nothing that you could factorize. So then what you do is you use this method where you cancel there and you cancel there. So you separate. So what I mean is the following. You're going to say negative 6, 3x over x4 plus 2 over x4. You see how I just separated? Nice. The next thing is you want to get rid of this cube root. So remember that if you have a b over there and an a over there, then the exponent rules from grade 9 already tell us that you take the inside number divided by the outside number. So there's a 1 over there. So we could then say dx. I'm going to keep saying dx until I actually do the first derivative. Up until this point, I have not done the first derivative. I'm just simplifying, making it easier for us to work with. So we're going to end up with minus 6x to the 1 over 3, good job, over x4 plus 2 over x4. Now I need to use exponent rules over here. Those exponent rules say that if you have, for example, a7 over a3, then what do you do with these numbers? Well done, if you remember that you subtract. And so that's going to become equals to dx. The negative 6 just chills on the front. Now x to the third, let's quickly simplify that. X to the third over x4 becomes x to the 1 over 3 take away 4. Now I'm just going to go type that on my calculator so long. Negative 11 over 3. Negative 11 over 3. Okay. And then over x. Oh no, we don't have over x4 because we've just done that. And then this x4 needs to come to the top. So remember, when you bring it to the top, it changes sign, so it becomes x to the negative 4. Excellent. We are now in the position to take the first derivative, and so now I'm not going to say dx, okay? Now I'm going to take the first derivative. So you know that if you have like x to the 4 with a 5 in the front, then what do you do with these numbers? You multiply, and so that's exactly what I'm going to do over here. So I'm going to say negative 6 multiplied by negative 11 over 3, and that gives us 22. Then I'm going to subtract 1 from here, and that would give us negative 14 over 3. And then I'm going to do this one now. So I'm going to multiply the negative 4 to the front, so that becomes negative 8. And then and then I'm going to subtract 1 from here, which is negative 5. In some of my earlier videos, when I used to show these examples, I used to say that you should then do one extra step where you change these back to positives. But in all of the recent exam papers, whether that's CAPS or IEB, they are not expecting you to change it. So you can now stop at these points over here. You don't have to then go to the next step and make this a positive again. So you can just leave your answer like that. So here's all the questions that we're going to do, but I'm going to split the questions up onto individual pages so that we can see a little bit better what we need to do. So let's begin. It says sketched below is the graph of f of x. Okay. I don't like it when they put an A over there. Normally A is over there, and that sometimes can confuse learners, so just keep that in mind. The x-intercepts of f are 3, 0, which is there, and m, where m lies on the negative x-axis. The value k is the y-intercept, and then m and n are turning points. Now, first thing I need to tell you, and you've probably heard me say this before, but if you haven't, take some notes on what I'm about to tell you. It's really important. When you have a x-intercept, which is also a turning point, then you need to remember that this counts as 2 x-intercepts. 2 of them, okay? So, yeah, that is important that you understand that, okay? There are 2 x-intercepts there, not 1, okay? So, the first question for 5 marks says, show that the equation of f is given like that. Okay. So remember, I have shown this in previous videos. Whenever you have the x-intercepts, then you can just make 3 brackets. Okay. And then you would usually say y equals, okay, I don't know why I squashed that up so ugly like that. Okay, so y equals, and I'd usually, I always remind you that you need to put an a, and then 3 brackets. But now what is that a actually? It's not that a, and that's why I don't like it when they do it like this. That a is the first one in front of the x3, because this is how they usually write it for us. It's that a, it's the one in the front of the x3. But in this example, that a is a, that value is a 1. So we can drop that. You can put a 1 if you wanted to. Then if you've seen videos on this before where you have your x-intercepts, then you're just going to make 3 brackets. So that's a 3. So you say x take away 3. Then x take away whatever this one's x value is. So let's call that x value of m. And then this one will be exactly the same. Because what did I tell you? I said that when this is a turning point and an x-intercept, it counts as 2 x-intercepts. Ah, good. Very good. So what we can now do is, and by the way, if this was like a 5, for example, or like a -5, then your brackets would go like this. X take away 3, x plus 5, it would become x plus 5, and x plus 5. Because you could imagine it goes, you would go x take away -5, and then x take away -5. And you see how it ends up becoming a plus. Okay, but we don't need to worry about m being negative or positive. You're just going to go put it like that, and the mathematics will work it out. Okay, so what we do now is we take this value and we substitute it. So that's a y value, that's an x value. So you plug that into the place of y, and then the x is 0. And look at that. Beautiful. The only unknown is the x value of m. So what I'm going to do is I'm going to say -3 equals to, this just becomes -3. And then this is just negative xm. Do you agree with me? Negative xm, because 0 take away xm is just negative xm. I'm then going to multiply these two together to become positive, because 2 negatives make a positive. So that's going to become xm squared, positive xm squared. I'm then going to divide this -3 onto the left side here. So you're going to end up with -3 over -3 equals to xm squared. And so xm squared is going to be equal to 1. And then if you had to go work out xm, you would say the square root, but you would say plus and minus the square root of 1. And so the x value of m is either plus or minus 1. But from the diagram, we know that m is a negative. And they make that clear to us, because some learners might be like, yeah, but how do we know that? M lies on the negative x-axis. So the x value of m has to be -1. Okay. Excellent job, guys. So now we have the x value of m as -1. So we can now come back to this step over here, and we can go fill in x as the x value of m as -1, like that, and like that, -1. Okay, and I hope you remember this method, guys. I have shown this in previous videos. So for example, if you have like this, and you have like a -3 here, a 1 here, and a 3 here, then you make 3 brackets, remember? And then normally you have to put a little a in the front, but in this one it was a 1, so I left it out. So then for this bracket you would say x take away -3, for this bracket you would say x take away 1, and for this bracket you would say x take away 3. And then you would just be able to get your brackets like that. Okay, I have shown that many times before, so I hope you were aware of that. Now, let's carry on. So I'm going to leave this one, it's not necessary. So we have x minus 3, x plus 1, and another x plus 1. In fact, yeah, that's perfect. Okay, now we just go multiply everything out. So when you have 3 brackets, you can multiply any 2 of them together. So I'm going to multiply the first 2 together so long. Actually, no, I'm going to do, it doesn't matter, but I'm going to do these 2 together. And then the first one will just stay there, and then you keep it in a bracket. Remember, when you multiply these 2, you still keep the answer in a bracket because we still need to use this one. And so if you had to go multiply that, you would eventually get x squared plus 2x plus 1. You might do that in little steps, x squared plus x, that's where I got the 2x from, and then plus 1. Now we need to go multiply these 2 brackets together. And so I'm going to do that, whoopsie, what was that? I'm going to do that up over there. So that's going to become x times x squared, which is x cubed, plus 2x squared, plus x, minus 3x squared, take away 6x, take away 3. Then I'm going to put all of the like terms together. So those 2, which is negative x squared, and then these 2 together, which is negative 5x, and then negative 3. Okay, and let's see, is that what they said? Yes, well done, guys, we've done it. Let's move on to the next part. Okay, this question says calculate the coordinates of n. Now that is the turning point. I've got the equation that we worked out previously. So, okay, so we know that to find turning points, which are those points over there, it is where the gradient of the graph is equal to 0. So you take the first derivative, which is going to be 3x squared, take away 2x, take away 5. Because remember, first derivative means gradient. And we're going to make that equal to 0. We don't always make it equal to 0 every time we take the first derivative. But when you are finding turning points, then you do make it equal to 0. A lot of learners are in this bad habit of whenever they take the first derivative, they just immediately make it equal to 0. But you need to understand something. The first derivative is another word for gradient. So the gradient is 0 at those points, and that's why we're allowed to make it equal to 0. Okay, now we're just going to go either factorize this or use the quadratic formula. I'm going to use the quadratic formula. The x equals to negative b plus minus b squared take away 4ac over 2a. You would have to show them how you fill this in the exam, but I'm just going to quickly go get the answers because we all know how to use that formula by now. And so x would be 5/3, 5 over 3, or x would be -1. Okay, so obviously this one is the m, which is -1, which we actually worked out already, that this x value is -1, and this one would be 5/3. So the x value is 5/3. Now, think about carefully. What do we need to find next? We need to find the y value. So does that mean we're going to plug it into this equation? No, because this is not a y value. This is a gradient. Remember, first derivative means gradient. So we're not going to plug it into there. If you did, you're just going to get 0 again. And that's not correct. You're going to plug it into here because this is a y value. So we're going to say, we're going to go plug in 5 over 3 into that point. Okay, and if we work this out, ooh, ugly number, -256 over 27. This next question says that for which values of x will f of x, which is this graph, For which values of x will it be smaller than 0? Now, we need to understand what that means, because I know a lot of you still struggle with that. They're saying, where is the graph smaller than 0? Now, what do they mean? Do they mean where are the x values smaller than 0? Because that would be all of this. No, they mean where are the y values smaller than 0? So if I highlight the graph here, in this area here, tell me about the y values. Are they negative or positive? Well, there the y values are negative, all the way up to there. All of that, the y values are negative, right? Of course not that point over there, because there the y value is 0. And then as soon as we go past that point, then look at that, the y values all become positive. So where are the y values negative? Well, it would be all of this up to there, and then just skip past that point, and then up to there, but don't include that point, because at that point and at that point the y values are 0, but they want to know where are they? Less than 0. So we could say that it's everywhere where x is, well, let's first say, if you wanted to use interval notation, you could say x is an element going from negative infinity up to this x value, which is negative 1, or from negative 1 up to 3, and we don't include any of those points. Okay, does that make sense? The next one, if you want to use interval notation, you could say that x is any number smaller than negative 1. Okay, that's the same as saying that. X is anything smaller than negative 1. Or x is any number that is bigger than minus 1, but smaller than 3. And that's the same as that part. You even allowed to say that x can be any number that is smaller than 3, but just don't let x equal to negative 1. You could even say that if you wanted to. Okay. This question says, for which value of x is the graph increasing? Now, increasing is when the graph is going up, when you're moving from left to right. So it would be all of this up to there, and then it would be all of this. You see, that's increasing. The gradient is positive. You see how the gradient is positive? Okay, if you look at this area, ooh, it's going down. You see how it's going down, so that is not increasing. Now, it's only for 2 marks, so we definitely don't need to go use calculus and all of that fancy stuff. We can literally just say that it's this area here, so that's everywhere where x is smaller than negative 1, because this is negative 1. And we're not going to include the negative 1. Some learners still get confused with this. At negative 1, is the graph increasing, decreasing, or is it flat? Well, most of you are going to tell me it's flat. So that's why we don't include negative 1, because they're not asking us where it's flat. They want to know where is it increasing. So we'll go all the way up to negative 1, but we won't include negative 1. Then the next part would be from x is larger than, now remember we worked this x value out earlier, and we worked it out as 5 over 3. So x is bigger than 5 over 3. Okay. If you want to use interval notation, you could say that x is an element going from negative infinity up to negative 1, or x is any number from 5 over 3 up to infinity. And once again, we're not including the 5 over 3, because at the 5 over 3 it is not increasing, it is flat. This question says, where will the graph be concave up? So remember, let's talk about concave. When a graph looks like that, does it look sad or does it look happy? Well, maybe if I put the eyes, that's a sad face. So this person is feeling very down. So we call this concave down. What about this person? Oh, this person's really happy, smiling. So we call this person's feeling up, like the energy's up. So we say concave up. So if you look at this graph, where is it sad? Where is it happy? Well, we know that somewhere over here, where it's called the inflection point, that's where it changes from sad to happy or happy to sad. So here it's sad. Look at that. See the sad face? And then here it's happy. See the smiley face? So they want to know, where is it happy? Well, it's definitely from here. But the problem is we don't know what here is. We don't know what the inflection point is. It's not K. So how do we find inflection point? Well, you should know this by now. To find the inflection point, you take the the second derivative, sorry, and you make it equal to 0. So we're going to find the first derivative, because you can't get to the second derivative without the first derivative. Wise words, Kevin, wise words. I know, guys, I know. So the second derivative is 6x take away 2. Make it equal to 0. Solve for x. Divide by 6. And you end up with 2 over 6, which is the same as 1 over 3. So the x value here is 1 over 3. Concave up, well, it'll be anything to the right of that. So you could say x is bigger than a third. If you prefer interval notation, you could say x is bigger than a third, and that would go up to infinity. Now, if you did not have the graph in front of you, then how would you be able to do this? Well, what you would do is you would say that the second derivative is positive or happy. Remember, when you have concave up, your second derivative is a positive number, so it's bigger than 0. And when you have concave down, your graph is sad, negative, and so you would say that it is smaller than 0, which is negative. So if you did not have a graph that you could look at, you could just say that you want the second derivative to be bigger than 0. You would then say 6x minus 2 bigger than 0. You would then say 6x is bigger than 2, divide both sides by 6, and you would end up with x is bigger than a third, which is exactly what we got over there. This question says, determine the maximum, okay, that's an interesting word, okay, maximum vertical distance between the graph of f and the graph of the first derivative over the following interval. Right, so you've maybe watched some of my videos on this before, but how do you find the vertical distance between any two graphs? Typically, like in grade 11, they would give you a parabola, and they would give you a straight line, and they would somehow ask you to find the maximum distance between the two. Now, well, what I would normally do in those types of questions is I would always say you need to have the equation of the top one. You see the graph that's on top, and then you need to have the equation of the graph that's at the bottom, and then you would say the top minus the bottom. Have you ever seen something like that of mine before? Well, we're going to use the same technique here. The only problem I see, though, is we have the graph of f, but we don't have the first derivative. But it's not a problem. We can quickly go find something here. So if we go take the first derivative, that's going to give us 3x squared, take away 2x, take away 5. This is a parabola. Okay, is it happy or is it sad? What do I mean by that? Is it happy like this or is it sad? Well, it's happy, okay, because this number in the front, the x squared term, is a positive number. Now, they've only asked us to look between -1 and 0. So what I'm going to do is I'm going to plug -1 into this equation because I'm just trying to get an idea of what the graph looks like, okay? So we're going to plug -1 into this equation. So that's going to look like this. And if you had to go work that out, you would actually end up with 0. So that means that when x is -1, the y value is 0. So that is exactly the same as this graph of m. I mean, this point m. It's exactly the same. Then I'm going to go plug in the other point into this equation. So I'm going to plug in 0 now. And you end up with -5. So when the x value is 0, the y value is -5. So if we go fill that in, it's over here. Okay, now we know it's a happy graph. So we know the shape is probably going to do something like that. Okay, so the point that I'm trying to show, though, is that if you look between the interval that they are talking about, which is here, who's on top? Is it the cubic or is it the parabola? Well, it's the cubic. We can see that the cubic is the one that is higher up. For example, if you chose this x value, if you look vertically, who's higher up? It's the cubic. If you chose this point, if you look vertically, who's higher up? It's the cubic. So that means we're going to say top minus bottom. So it's the cubic equation. So we're going to say vertical distance is going to be equal to the top equation, which is x cubed, take away x squared, take away 5x, take away 3, minus, in brackets, the bottom equation, which is this. So 3x squared, take away 2x, take away 5. We're now just going to say this as much as possible. So I'm just going to get rid of these brackets. Okay. And now I'm going to just put all the like terms together. So we're going to end up with negative 4x squared. So that's, I put that one and that one together. And then negative 3x, that's by putting that one and that one together. And then positive 2, that's by putting that and that together. Okay, so there we have the vertical distance. This formula gives us the vertical distance. Now, what are we trying to do, guys? Well, we are trying to work out the maximum vertical distance. In grade 12 calculus, whenever you want to find a maximum, for example, on some type of graph, if you want to find the maximum, how do you do that? You take the first derivative and you make it equal to 0. So we're going to take the first derivative of this equation. So we could say that we're going to take the derivative of the vertical distance. You could have called that distance or whatever. And we're going to do that with respect to x, so dx. Okay, so if we take the first derivative, that'll be 3x squared, take away 8x, take away 3. We're going to make that equal to 0. Okay, because that is how you find maximums and minimums. You make the first derivative equal to 0. We're now going to go solve for x. Okay, so we've made this equal to 0. I'm going to use the quadratic formula, okay, because I don't feel like factorizing that. And if you do that, you end up with x equals to 3, or, now it can't be x equals to 3 because we're only going between negative 1 and 0. Then the other answer is, here we go, x equals to negative 1/3. So we cannot use this one because that is outside of the domain that they have asked us to use, but this number is still within the domain. Now that's not the answer, that just says the x value, so that just tells you where about the maximum is. So they're saying that x is negative 1/3, which is probably there, so they're saying that that is where the maximum is. But now if you actually want to find the maximum, you can just go plug it into this formula here, because that formula gives you the vertical distance. If you want to maybe go plug the x value into this one's equation and plug the x value into this graph's equation and then subtract them, some learners like to do it like that, you can, but I just like to keep it easy and I plug it straight into this formula because this formula is giving us the vertical distance. And so I'm going to go plug in vertical is equal to, now we're going to say negative 1/3 to the power of 3, take away 4 to the negative 1/3 squared, take away 3 to the negative 1/3 plus 2. And if we go work that all out, we end up with, if we round to 2 decimal places, 2.52. Flags from 4 African countries and 3 European countries were displayed in a row during the 2021 Olympics. Okay, so you've got these 7 flags, sorry. 4 from Africa, 3 from Europe. Okay, the first question says, determine the total number of possible ways in which all 7 flags could be displayed. That's a nice easy question because they're not saying that the African flags must be next to each other or anything like that. So you could have an African flag, like I'll call that A1, and then you could have a European flag, and then you could have another European flag, and then you could have an African flag, and then another African flag. It doesn't matter. The order. So the answer is just going to be 7 factorial, but let me explain. So if you have 7 opening places, and you standing over here, and you have to decide which flag are you going to pick first, how many options do you have? Well, you have 7 options in front of you. Then your next flag, you've got 6 of them left over, and then there's 5 left over, then there's 4, then there's 3, then there's 2, then there's 1. You would multiply all of that together, but we know that if you're counting from a number all the way down to 1, you can just say 7 factorial. And if you work that out, you end up with 5,040. Okay, now this one says, what is the probability that the flags from the African countries were displayed next to each other? Okay, so what you do in a situation like this is you pretend that the African flags are next to each other, okay? So if you've ever watched my videos on what to do when they want you to group things, well, we're going to use that technique. So check this out. Let's say we've got African flag here, African flag here. So we're putting all the African flags next to each other, okay? Then we're going to put the but no one said the European flags have to be next to each other. So learners always think, yeah, but surely it means that they have to be. No, you could get a situation like that. They just said the African flags must be together. So what we do is we put all the things that have to go together in one big box, Okay, so we think of that as one big box. So how many boxes can you now see? Well, there's one big box, then there's a second one over here, a third one, and a fourth one. So then you say 4 factorial. Okay, then you look inside each of the boxes. So inside here there's only a 1, inside here there's only 1 item, and inside here there's only 1 item. So we will ignore those. But inside this big box there are 4 items, and so you could shuffle these around within the box, and so that's where we say another 4 factorial. If you had to go work this out, this is not the final answer because they asked us for the probability, but that's 576. Now they said the probability. So you could say 576 out of the total number of ways that these flags could be arranged. And if you just type that on the calculator, let it simplify, 4 out of 35. And by the way, if you watch this last question over here, and you are confused with what I've done over here, then you need to go look for some of my other videos where I talk about probability and I show how that technique works, where you've got, for example, books that need to be together or people that need to sit next to each other. It's a strategy that I've taught in those videos. This question says that A and B are independent. Let's stop right there. When 2 events are independent, then mathematically you can say that P of A and B is equal to P of A multiplied by P of B. This is called the formula for independence. Okay, what? I made that sound more fancy than it is. This is just the independence formula, okay? It's the formula you use when things are independent. So that's important to understand. And then they give us PA, PB. Okay, so whenever they give you all of these numbers and all this blah, blah, blah stuff, you need to use the main probability formula that was taught to us in grade 11, which, let's go have a look at the formula sheet. I'll show you which one I'm talking about. Here we are on our formula sheet, and it is this formula over here. It is the most fundamental formula in probability. It is very important. So let's go write that one down. So P of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. The next thing is that if we know that 2 events are independent, which they've just told us, we can use this formula, which says that P of A and B can be rewritten as this. So on the next line, I am going to replace this with P of A multiplied by P of B. Okay? Now we just go fill in and have fun with this thing. So P of A or B is 0.88. P of A is 0.4. P of B is what we're trying to calculate. And then here it's P of A again, which is 0.4. P of B is what we're trying to calculate. And there we go. So let's just write this a little bit better. Okay, so now we're just going to solve for P of B. So we can take this 0.4 over. So it becomes 0.88 take away 0.4. Here we have 1 P of B. And here we have 0.4 P of B. So we're going to say 1 PB take away 0.4 PB. And so you're going to end up with 0.48 on this side and 0.6 on this side. And so if you had to divide both sides by 0.6, you're going to end up with 0.48 over 0.6, and that would be a final answer of 0.8. This question says that there are 120 passengers on an aeroplane. Okay. Passengers have a choice between a meat sandwich or a cheese sandwich, but more passengers will choose a meat sandwich. Okay. There are only 120 sandwiches available to choose from. The probability, okay, so we all understand so far, right? We've got this aeroplane with 120 people. They can choose either to eat a meat or a cheese sandwich. Statistically, they know that there will be more passengers who choose a meat sandwich. Okay, but there are only 120 sandwiches to choose from. Here they tell us that the probability that the first passenger chooses meat and the second passenger chooses a cheese is this. Calculate the probability that the first passenger will choose a cheese. Now, if you read that and you start doubting your life choices as to whether you should have chosen Maths Lit or Pure Maths, I fully understand. Even when I read that, I'm just like, oh my goodness, can I just walk out of this exam right now? So, Right now, because remember, when I do these recordings, I never know the answer before I do it. Like, I have not looked at the memo. If you know anything about me, I hate looking at the memo unless I have finished the question. But I will not look at the memo. I'll even sit here and do this for an hour. I'll pause this video and I'll try figure this thing out for an hour if I get stuck before I look at a memo. Okay, so what was my point? Oh, my point is that right now when I've read that, I'm feeling a little bit like, what the hell was that all about? But that's normal. I feel like that many times. Okay, so if you feel like that in an exam, it's normal. Now we just got to slowly try to figure this out. And I know that in an exam, you're pushed for time. Your palms are already sweaty. It's really nerve-wracking. I understand that. Okay, so yeah, right now I have no idea, but I'm going to read it again a few times. And I'm going to push pause now, and I'm just going to read over it a few times and try to make sense of it, but I will never look at the memo. That is a guarantee. Or what they said here was that there was a first passenger and there was a second passenger. So what I'll do is I'll say first passenger, second passenger. So this is the first passenger, and this is the second. Now, in probability, whenever you have something and then something else happening, we just use multiply, right? So for example, now what I'm going to do is I'm going to say let's say all the meat sandwiches, let's let that equal to x. So then all of the cheese sandwiches, there would be 120 minus x, because there's only 120 sandwiches. So if there's x meat, then there's 120 minus x cheese. So the first person, they told us that the probability that the first person chooses meat. Okay, so if the first person, what is the chances that they're going to choose meat? Well, there's x meat sandwiches, and there's 120 sandwiches altogether. When the second person makes a choice, there are only 119 sandwiches left. And how many cheese sandwiches are there? Well, no one has chosen a cheese sandwich yet, so there's still going to be 120 minus x, okay? Because no one has chosen a cheese sandwich yet. So, and they tell us that this probability is 18 over 85. 18 over 85. Okay, so we don't need to get a common denominator because we're multiplying. We're not plussing or minusing. So I'm just going to multiply these two numbers together at the bottom. So that's going to be 120 multiplied by 119. And that's going to be 14,280. At the top, we're going to have x and 120 minus x. I'm just multiplying them together, okay? Then on the other side, we have 18 over 85. Now, whenever you have a fraction equal to another fraction, we use cross multiplication. So this part can go there, and this part can go there, okay? So what that means for us is that this part is going to go there, and this part is going to go to the top left. Okay, so we're going to end up with 85x 120 minus x, and on the other side we're going to end up with 18 multiplied by 14,280. Okay, now we're just going to multiply this 85x in, so that's going to be 10,200x, take away 85x squared, and then we're going to multiply these two numbers, and that's going to be 257,040. And now we just have some type of beautiful looking equation or trinomial. So I'm going to take everything to the right hand side. Okay, so we're going to end up with positive 85x squared minus 10,200x plus. Okay, so there we have our equation. Now I'm just going to use the quadratic formula. Okay, but I'm not going to show all the steps. You guys know this by now. Oh, and you know you're right when you're getting nice answers. So we get x equals to 84 or x equals to 36. Okay, so now be careful. They said that that's the meat. Okay, so there's either 84 meat or there might be 36 meat. But remember, there's only 120 sandwiches in total. So it cannot be the 36 meat because then there would be more cheese than meat. But they said more passengers will choose meat. So it has to be this option here. So we cross out that one. So we can say 84 meat. Okay. And then what is 120 minus 84? 120 minus 84 is 36. So that would be cheese. 84 meat, 36 cheese. Now we haven't answered their question yet. The first question says, Calculate the probability that the first passenger chooses a cheese sandwich. Okay, so imagine the very first person is about to choose. How many sandwiches are there? There's 120. Of those, 36 are cheese. So we can say 36 out of 120. Go ahead, type that all in, and there is a 3 out of 10 chance.